Hey everybody, how's everyone doing? Hopefully you have found the room. If not, we are live right now. We're doing an experiment here. Hopefully this works, and hopefully you guys can hear him. I got David on the other line. If you guys remember David, he was on our live stream a couple of days ago, back in Earth, and you guys were talking with him about printers and talking about stuff. I decided to bring him on so we can do a one-on-one talk about all the equipment that we're using and to bring on. Unfortunately, we were having nothing but technical difficulties all day today, unfortunately, but we finally got him on. So, Daniel, say hi to everyone out there. Well, so far we only got one viewer so far. So if you do have a chat, please type in yes or no. If you guys can hear him okay, let me know. So why are we on together? Well, one, we're friends now. Well, we were friends basically at Earth. We met each other, and yeah, yeah. Okay. Can't hear him. What do you mean you can't hear him? Okay, hang on a second here. Uh, yeah, it is. Man, I can do the video capture device. Has no microphone on it. Webcam. What? Are you sure you guys got hearing the desktop audio from him? Say a few words again. Oh, I see what's going on. Hang on. Can't read libs either. Haha. That's from Minnesota Maker. Let's see here. Let me try something else, guys. Ouch. Okay, guys. I am right now rewiring this whole basement where my computer is. I'm going to pump audio through this, whether it kills me or not. Okay, try now.
Hello, hey guys, can you hear me? Let's check it out. Testing, 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 testing.
I'm seeing
How's that
desktop
working for you?
audio, so this is looking good.
Okay, okay. What do the viewers say? Consensus? Yes, no?
I'm still waiting for them to reply.
We'll see.
Yeah. But anyways, the reason I brought him on is he is basically the print whisperer. Yeah, I do apologize for the delay, guys. It's nothing I can do about that. Unfortunately, it's the way the software is working tonight, so I do apologize greatly.
Yeah.
So they
Well,
can
we're
hear
on.
you. So
Can you hear me?
yes.
Awesome. We're going.
Okay. So what we are here, if we're going to be talking about printers, we're going to be talking about calibrating a printer. I also got a printer, as you guys know, is the X1, which is a piece of junk. But what we're thinking of doing is, it's okay. I'm just giving you grief. Thanks very much, Minnesota Maker. Thank you very much. Hey. Actually, you know what? I'm going to give you the same
Yep.
view here. Hang on a second here. So you can see
There
me
we go.
better. There. Can you see me better now?
Yeah, there we go.
Okay.
That's better now.
Good. Yeah, so unfortunately he's having computer issues, so we are connecting using Facebook, and he is on screen number 2, so we won't be doing any screen-to-screen display magic stuff tonight, so I do apologize for that. But what we're trying to do is we're trying to look at this as a, I got an old printer here. I got a printer here that's basically brand new, but I've hardly ever used it because I really have nothing I can use it on. So here's the situation. The printer is the X1. It is it's an FDM type style printer.
Uh-huh.
It only has one arm to control the printer. The head rolls on the 10 by 10.
A cantilever sort of sticking out, right?
Yeah, cantilever,
All of
exactly.
these slot wheels. Yeah.
Yep.
And the bed moves the other way. So
That's
you got
correct.
one that goes like this, and one like that.
That's
Yeah.
correct. The Y goes back and forth. The X goes left to right. Yeah.
Yep.
And the Z goes up and down. Thing is,
Yep.
the mortars are good. They're super quiet though. So I don't know if they're underpowered or if that's as powerful as they get and there's no use for those motors in any other type of build. And I can bring the printer in so you can have a look and we can go over it.
Yeah, we could do that. Look at that on camera in a bit.
Yeah, definitely.
First, we can just talk about some of the stuff in it. So, what sort of problems are you having with it so far?
Well, okay. Best examples. If I had still the prints kicking around.
Print examples. That is really helpful. Well, you know the phrase, a picture is worth 1,000 words, right?
Exactly.
You know,
unfortunately,
and when it comes to 3D printing, a picture of a physical object is worth, 1,000 pictures. I mean, it tells you everything.
Like take the CR10 cat here for example.
Mm-hmm.
Okay.
Yeah, nice print.
Everybody, there's the king. Apocalypse Surveyor says, "Hey, I need a minute to rearrange my life." BRB. Okay. And Mad Mike says hi to you, Daniel.
Hey.
Daniel, do you have access to YouTube, or to the chat window, or no?
No access to the chat window. But if you can relay things, if anybody's got questions, I can take all that.
Well, I was going to get you on the chat window if we could, but so that's the CR10 cat, guys. So the print is actually in very good condition. Now, what the X1 did, when I put it through the X1, it actually caused a lot of Z-banding going right around the whole object.
Z-banding, Z-ribbing, Z-wobble. There's something I could talk about for a while.
Yeah.
Yeah, okay.
There's no part cooler on it.
Mm-hmm.
And it will only do PLA.
Okay. Heated bed? No heated bed?
No heated bed.
Right bed? Okay. All right. Pretty limited. Because this is tough. See, with PLA, generally you want a part cooler. And for machines without a part cooler, generally what you'd use them for is like ABS. But you can't really do that very well without a heated bed. So you're kind of stuck in this position where it won't really do PLA because it doesn't have a cooling fan. And it won't really do like ABS because it doesn't have a heated bed. So what do you do with it? Yeah, interesting.
Yeah, so it was to get me into printing, and we heard a lot of good reviews. I mean, you look at Press Reset by Preston. He was blown away by the printer. He's like, the thing's $150, and it prints like a monster. It actually produces half decent prints, and I will agree. 9 out of 10 times it produces a very good print. And then other times it's just like, and you're just looking at it, you're just going, why are you printing this bad again?
Yeah.
You printed this beautiful rocket, yet you printed this. Hey, John DiCaprio, thanks for, hopefully I'm pronouncing your name right. Yeah, he just put his hand up, like saying he's here. So thanks for coming in, man. I do appreciate it. I appreciate everybody. And if you're new, don't forget to hit the subscribe, hit the bell, find out when we go live. But anyways,
yes, definitely do it.
Yep. We're at 109 subscribers
so John's
now.
Another Facebook friend.
Oh, that's one of your Facebook friends?
Nice. Yeah, John's one of my Facebook friends.
Oh, okay.
He's just like you. I've known him for a while on Facebook. We chat back and forth, right? You know, kind of like how I met you in the printing groups.
Yeah.
And then I finally met him at Earth a couple weeks back. So.
Well,
cool.
John just signed up as a subscriber. Oh yeah, baby! Thank you so much. We just got the zombie that runs across and goes, "Oh yeah." Yeah, this is like the zombie going.
All right.
Oh, he says, "I thought we were real friends." LOL or haha.
Oh, now we are.
Oh, I see. That's how it works. Okay, so you have to.
You have to meet in person? No.
John, thank you so much for joining us. Something I got for you also. I forgot to give it to you at Earth. Because I just got.
What's that?
Well, lots of neat little stuff here. But Country was going crazy, and I meant to give you these. So you got a Country Club sticker coming towards you. Oh, sorry. Let me hold it the right way. Everybody knows this sticker. Just showing it to the first people and then to you. And Country 3D gave me an extra sticker, so I'll be trying to get these out to you then.
Cool.
Okay. You know, who doesn't need more stickers?
Oh, I
And
need
since
stickers.
a lot of people complained I didn't have Chris's basement tile sticking up,
Yeah.
people, it's right on this pole right here. So sorry you can't see it right now, but stay. There you go.
Yeah, good boy.
See, John, I did it for you because you complained about it. It's now up there, right there. So John Mack just entered in. So thank you so much, John Mack, for joining us. So we're talking about the X1 situation. So we're trying to figure out a way what I can do with the X1. The idea is turning it to an ANET printer. Was one of the ideas I had. You know, where
turn it into kind of an i3 clone, be more stable than a cantilever.
Exactly. Right. And I'm just wondering if there's a way. I'll bring the printer out here right now so you guys can have a good look at it. Mm-hmm. But
sure.
Why don't you talk about what are the three, like, what's the cause that can happen? Why does Z-band happening, and what could cause it? You know, so if someone has a problem with Z-banding, they can come up with an idea while I go back here to how to get to the bottom of it.
Sure. Well, I've seen several different types of Z-wobble or Z-banding. You can generally classify it into one of several types of issues. There's a good article about it that I think I still have a link to. I'll send that over to Ron, and he can drop it in the comments for you guys to see. But I'll have to remember that. That's what it is. Got it. Okay. So there are several different classes of causes for stuff that we would call Z-wobble. One would be strictly mechanical banding, which can come from several different sources. One would be an interesting thing that usually only pros bump into after they've really ironed out like every single possible issue, and then there's a very slight amount of banding left that no mechanical things can get rid of. And then there's a third interesting set of Z-wobble-like symptoms that are actually caused by electrical issues. So you can generally group Z-wobble or Z-banding or Z-ribbing into these three categories. There's like gross mechanical issues, there's a very tiny electromechanical issue, and then there's a class of electrical issues. So I can talk about the electrical one first, because this is surprisingly common. Usually only see this in printers with heated beds. If the heated bed is sized a little too big for the power supply, or if the heated bed is single-sided and not very well backed, both of which might happen in cheaper printers, but not so much in more expensive ones, then one of two things can happen. Every time the heated bed turns on, you might starve the machine of current, because the voltage will sag a little bit on the power supply. And one thing that can happen is your nozzle temperature might drop. This is pretty common. The other thing that can happen is the bed can flex or breathe, I've heard it called. If you don't have a very stiff print surface on top of that PCB bed, a PCB bed, single-sided, is liable to breathe a little bit if it's in bang-bang control. Now, I don't know if you guys know what different control schemes are. Bang-bang, does that ring a bell? You want me to explain that, Ron?
Oh, I'm not seeing anyone saying anything like, what do you mean by bang-bang? So,
okay.
If someone asks a question, I can always come back to that, and we can go a little bit deeper into what the bang bang. Actually, sure. I just see one person going, "Yep." So I guess they've experienced bang bang before. They have an idea of it. Mad Mike does, sure. But I haven't seen anyone else. Yep, please. From
please.
Do you mean
pie
or bang bang style? What the heck are you talking? Pie? Have you ever heard of a pie or bang bang style?
PID, PID.
Oh, probably. No, he's saying paid.
Type. Yep.
Yeah, PID. Yeah, PID or bang bang style. Yep. Okay, so I guess they understand it. So,
Yeah. So PID and Bang Bang are the two systems that are implemented in Marlin. There are different types of control loops intended to just keep a set variable, say the temperature of the bed, around a target variable. Bang Bang is easy. It's just like if your temperature is below what you want, you turn the bed on, and if the temperature is above what you want, then you turn the bed off. So it kind of hovers around, but as a result, your power consumption goes, bang on, bang off, bang on, bang off, and your power consumption just like flip flops between really high and really low. Um, PID, or PID, stands for proportional integral derivative, which is a type of kind of calculus. It's a differential equation. Is much more sophisticated, but pretty well figured out in industry. I mean, they use it for all sorts of things, and there are different variations of that now. Even in some 3D printer firmwares, like RepRap firmware has a different version of that for hot end control. But PID loop control on the bed or disabling the bed will get rid of those sharp current spikes. So if somebody's having an issue with a printer that's making Z wobble whenever the bed is on, I would check. And like first things first, I just try doing a print and then turn off the bed. And if the wobble or banding abruptly stops beyond that point, well, boom, you tracked it down. It's connected to the bang bang of the bed. You can troubleshoot it from there. But usually that's not what it is. Often in these cheap printers, it'll be mechanical. That's just the first thing I would always check for, because it's an easy thing to test, right? You just start a print and like maybe a spiral base or something, and then you just go up a ways and you just turn off the bed after a while.
Yeah.
If the problem fixes it, then you found it.
Well, John Mark just posted it here. He says, for whatever reason, I've tried to do PID on my A8 bed, and it just crashes and resets, so I'm stuck with Bang Bang.
Got it. What specifically crashes and resets? Is it the firmware, or is it like, are you trying to compile firmware for it? Let's see what he says.
Yeah. But let's get into the printer I have here, so you got an idea what this thing does.
So this one here, yeah, this has no heated bed. The only real electrical draw on it is your motors and your hot end. So this isn't going to be susceptible to that particular class of issues.
So there's the one.
All right.
Motors down there.
All right. The belt, and does that belt run around that extrusion? Am I seeing that right?
Yes, that's correct.
On the end.
Yeah, so it wraps around on here, on this end, and on the bed in front. So if I can get the bed to tip a little bit, so I can do this.
It's compact. I like it. It's a neat design.
Yeah, what I really like is the bed itself, what it's made out of.
Yeah, let's take a look at that.
Yeah.
Honestly, I haven't done a whole lot with unheated beds. I work with heated beds for pretty much everything. So.
I prefer a heated bed any time of the day.
Oh yeah, of course.
So this is so this board right here is the same type of stuff that's made out of chipsets or chipboards are made, motherboards and such are made out of Gavolite.
Oh.
So you can flex it and pop your print
like a
right off.
Reinforced plastic.
Yeah, but you can bend it and pop your print right off.
Got it. So how does it fix to the plate? Is it like clip on just around the edges, or
these mini little clips?
Got it.
Yeah. Just showing it to the other camera.
Have you guys ever heard of Swiss clips? I don't know if you guys have ever heard of Swiss clips, but
I've
check
heard
that out. They're in little. Yeah, I mean to get some. Haven't really had the need yet, but I mean they're just so low profile and they look so good. I've been really thinking about getting some just to kind of clip the beds on, but stay out of the way.
Okay, so here's what John has told me. As soon as I try to start PID, tune, Octoprint disconnects, and printer resets. I think I have a stock A8 firmware. Do PIs on bed, but I'm having issues with Marlin. Yes, I have to disable Bang Bang to enable PDI. It's enabled. I just can't PDI tune. Sorry, PID tune.
Okay, so he knows that it's enabled, but he can't PID tune it. I see. That could be one of several things. What board specifically is in that, and what branch of Marlin
He's
is he
saying it's a
dealing with?
Marlin board. Hasn't told me what type
Is
of
it
board yet.
is it like a Ramps 2560? I mean, is it a ATmega 2560 chip based system?
Yeah, I'm waiting for that to come through. But like
That's most
these,
common.
like this one right here, for this printer, it doesn't give me any information on what the drives are. So what I'm seeing on this printer itself, from what I can read here,
Yeah.
it's telling me it's a Troxy, and it gives me a lot number, and that's
Okay.
the only description I can find on here.
Can you
That
show me the bottom side, the board or anything? Can you
well, this is the
show
board
me the
box
layout of the board?
itself.
I haven't seen one. Okay, there's a control box.
Yeah, I
I
do not
haven't
like this
ever
control
cracked
box.
open one of those trunk seats, so
Uh,
interesting.
yeah,
Well,
I
do you have some screwdrivers handy? We could
I do.
peel
I
it
can
open and
open it
take a
up.
look at the
Hang on.
electronics in there.
Yeah, let me open this baby
Cool.
up then.
All right.
Ah,
While you're doing that, you mind if I talk more about Z-Wobble?
go right ahead. Actually, hang on a second here. Uh, okay, some stuff just came up. He says stock 8 board. Apocalypse the Virus said
Okay.
I also had to reset when tuning on the bed after installing the auto PID slash generated value. Then it says 1.1.8 and
1.1.8. Okay.
yeah. Now John says he thinks that these are 21 or 1280s for the stepper
Okay.
mortars.
1280s.
Yeah, that's what he's saying. But I'll go grab a
Wait,
screwdriver. We'll get into there.
1280 processor? Or is that what he's saying?
I think he means my stepper mortars are 2080. Ah, here it is.
For
So
motors?
Apocalypse of Virus says his is a Ramps remake on a Genuine Mega.
Okay. Okay, that helps.
Yeah.
I'd have to think about that. And
Yeah,
so it's
Tanner's.
running Arduino 1.1.
We also got Tanner 3D listening while he's driving. So thanks for coming on
Oh,
there, Tanner 3D. He's just listening. He's not basically watching the video. So that's okay.
yeah.
You know, I'd rather you drive safe than anything else, Tanner. So, take care of driving there. So if you want to go on about that, I'm going to go grab the screwdriver and we'll get into this thing and get this taken care of. So you can see the board.
All right, cool. So, let's see, Z-Wobble, where do we leave off? Okay. Now, Z-Wobble, I've seen several different names applied. There's Z-Wobble, Z-Banding, Z-Ribbing, stuff like that, basically to refer to various types of Z issues. And by that I mean really XY issues that are periodic in Z. So you see that either with the print like shifting or growing. It might be like wobbling like this, or it might be wobbling in circles, or it might be like various types of things. As long as they look reasonably periodic along the Z, they can be called the Z wobble or Z ribbing or something. The nomenclature is a little confusing and it's not quite standardized yet. The one thing that I have seen standardized and that I do push to be standardized is if they're going to call it Z wobble, I prefer that refers to one specific type of issue. So Z wobble in the classical sense is an issue that you get when everything is working fine except for this one specific error. As the nozzle moves upward relative to the bed, something in the lead screw system is not totally true. So maybe the lead screw is bent, maybe the lead screw is just simply out of alignment, maybe the shaft coupler that holds it to the motor is out of alignment, whatever it is, usually one of those two. It will push whatever kind of carriage you have around. Maybe it's a moving bed, it'll push the bed around. Maybe it's like a Prusa where just the x-axis moves up and it'll just displace the x-axis around. And this is very, very, very small. I mean, these can be tiny, tiny issues. They don't have to be very large, but you can still see them. The human eye is a really marvelously perceptive tool for looking at these things. We can see things on the micron scale. Think about it this way. imagine that a lead screw, it doesn't work exactly like this, but this is a ballpark estimate. Imagine that the lead screw in a 3D printer is 1/10 as stiff as the rods that hold whatever, you know, carriage you're moving upwards. Say it's a Prusa style, the i3, like an ANET A8. We've all seen those. Imagine that the screws that push that X gantry up in Z or Z are 1/10 as stiff as the rods. This isn't that far off of an estimate. I mean, that's totally reasonable. If those rods are wiggling by a millimeter and you constrain them too bad, that 1 millimeter of wobble that they want to express is going to get shared, so to speak, with the gantry as it moves up in Z. And the lateral displacement, the pushing that it does on that, is going to get expressed in the print. Now, there's something used in statics and dynamics. It's called superposition, which is a way that they can solve certain problems like these where things are over-constrained. And when you do the math, you figure out if the lead screw would be about 1 millimeter of wobble, then about 1/10-ish of a millimeter of wobble will be expressed by the nozzle. Now, 1/10 of a millimeter doesn't seem like much, but remember, the size of the layers we're dealing with are on 1/10 millimeter scale. So is the nozzle. The nozzle is, measured in tenths of a millimeter. So that actually is a pretty significant amount of wiggle when you look at the size of the features and the traces that we're dealing with. So even if the nozzle is just getting pushed around 1/10 of a millimeter, that totally shows up in the print. You can see that. And the trademark for Z-wobble, the one way you will instantly know if it's Z-wobble, is if you take that print and you hold it up to the screw, and you hold the screw and the print side by side, and the period of the wobble exactly matches the period of the screw. That means, if they exactly match all the way up, that means that the screw is guaranteed, pushing back and forth, and that was what was causing that periodic, right, left, forward, backward, whatever it is, maybe circular, maybe elliptical deflection in the nozzle relative to the bed.
Okay,
so that's classical Z-wobble.
According to what I've been able to find out, Apocalypse Survivor says he's worked around mine by restoring the value to default PID value that came in 118. But I wish I knew a better understanding of the three values, KI, KP, and KD, and the formulas.
Sure.
Mark said that he did a video on that. Joe Mike did a video on PI tune. Do the auto tune, and then it'll give you the values to put back in the configuration file. And he says that the PDI that he did is now working on his FS5.
Okay. Yeah, Joe Mike is a great resource. Joe Mike Tiernell is a great guy. I would check out his videos. I'm pretty sure he's done a video on PID tuning, like you said. That rings a bell. And if that's true, I'm pretty sure that would be a good guide, a good place to start.
Okay, so you said you wanted to see this board, so I got it right here.
Let's see that board.
Just trying to get it because the wires are so short of this bloody damn thing. That's another issue I have with this. But there's the board right there, guys. Hopefully you can see it.
Ooh, is that a Melzi?
It is a Melzi board.
I recognize Melzi. All right.
Yeah.
Okay.
This is Troxy's Melzi. This can be actually found on AliExpress. They have the board on there.
About $20 a pop, right?
It's about $25, yeah.
Something like that. $25? Okay. Yeah, I'm actually looking at using some of those for. I can't tell yet. It's a secret. School projects coming
I know about it, but we can't tell you guys.
He knows about it. We can't tell yet. It's
so
cool.
here's
really
a nice little thing, okay, with this board, and this is why I'm kind of debating on using it. Number one, in here, you have your power here. So the first green one's your power. Second one's for a heated bed. So it can control a heated bed. The problem is the type of connector it uses is only 12 volts.
Got it.
So it uses one of those barrel connectors.
Got it. Yeah.
So what has to be done is there's got to be a way to connect a full power supply directly to the board itself.
Yep.
So we would have to come up with some
the connector right now that's feeding the board is not going to cut it.
No, and I'm not sure on the voltage itself has enough voltage going through that board to power a heated bed.
Fine.
It's turned
you should
off.
Be able to power that. Yeah.
Right now it is turned off. You can't access the board at all. You have to somehow jailbreak it, aka update the firm, crack the firm so you can put a bootloader on it, so you can put the new firmware on it. It uses the Repetier firmware. Actually, it's not using the standard Marlin.
Marlin?
Yeah, it's not using Marlin.
Yeah, not as common, but I think CNC uses that. Some other people use forks of Repetier. It's good, mature firmware, just a little different than Marlin.
Yeah. So the other thing I want to do to this was I hate the screen that's on here. Ouch. Ah, Jesus.
You sing yourself with those wires?
Yeah, I just whacked the eye. Luckily, I closed it in time, but
whoops.
This thing is the most annoying screen ever. Listen to this click. Just listen to the clicks. Yeah, I hate the clicks. Ugh. And when you're scrolling through the software, so you would press down, and then it will wipe out the screen, and then it all rolls back with the new information on it. It's just horrible.
Slow refresh, yeah.
And the screen quality is that blue on blue.
Yeah, the viewing angle is like tiny. You got to be looking at it just right on.
Exactly.
Oh, yeah.
So what I was looking at doing is changing up the screen itself and getting an amber screen. So the writing is in amber and the background is black. But trying to find a 20x4 LCD screen, almost impossible. I can find 16 by 4. I can find 16 by 20.
But 20 by 4.
I can't seem to find 20 by 4.
So finding a drop-in replacement that's in amber might be kind of difficult. However, if you do manage to bootload it and crack that thing open and put your own firmware on it, which I would recommend for a couple reasons, then you'll be able to change the screen type. And if you find an amber screen you like, you could just configure it for that in Marlin.
Yeah, and that's what I'm thinking of doing is just getting a screen that's going to match the 20 by 4 and just change the screen out and not have to worry about changing the power wattage or anything like that. Just makes it easier.
Yeah. Depends.
But it's like this controller I'm not a big fan of. I'd rather have the rolling knob idea like you have on the CR10 and the ANETs and everything else because it makes it easier to select.
I like the knob.
Yeah. This clickety buttons gets annoying after a while.
Plus the buttons tend to wear out.
I'm not near the mic, and you can hear that click. So micro switch clicks. Yeah.
Yeah.
Yeah, it's just rough. Mad Mike says I should upgrade this to an Xbox 360 power supply.
Yes, that's a good choice. A lot of rep wraps used to use Xbox 360 power supplies.
Really?
They're designed to be run for long periods of time, right? They run electronics, so they got to be reliable. They have to have really steady current with low ripple, low noise in the line, so that they don't disturb the electronics. They're designed to run like a graphics card and a whole bunch of other stuff in that Xbox. So they have to put out a fair amount of juice, and it turns out, it's quite enough to run a printer. So Xbox 360 power supplies are good.
Okay, because I prefer playing my Xbox 360 that's over there.
Well, you can find one off eBay or something.
Yeah, that's true. I buy a used one. Buy a used Xbox, and I got a secondary one as backup.
That's true.
Speaking of we're going way off topic. Here's what I've been told. Okay, someone says, "Wow, small." After the Joe Mike, it says, "Does it have a heated bed on the output of the board?" It does.
Yes.
Then John Max says, "Cool." And then he says again, "You can use a X160 connector." Yeah, I could use an X160 connector. That is true. I'd have to find one, but yeah, it can be used.
You do that.
It says, how many watts is the power supply? Well, the the watts of the power supply, it's a 12-watt power supply that they gave me. I don't know how many amps it is. I don't have that in front of me, so I do apologize about that. Let's see. Same control buttons.
Probably like 5 watts or something. It's probably like, or sorry, it's probably like 5 amps, like 60 watts or something in that ballpark.
Yeah, I think it's like 5 amps. I think that sounds about right.
Is that what it is? It's around there. So definitely not to run a heated bed.
Yeah.
No way.
John DeCappa says print a spacer. Okay. Yeah, Mad Mike was the one that says need to upgrade and have, go to 650. Understandable. Then Mad Mike said if the bed is aluminum, just stick a low watt Caboton film on a silicone heater. They are 16 by 18 amps. A Dell DA -2 Ultra small form factor power brick is 18 amps and runs around $15 on eBay.
Send me a link to that. That sounds cool. I would love to have a link to that.
Which one?
Yeah. The little small form factor power supply. I'm doing a lot of research on that sort of thing right now.
Okay.
See if you can find that.
Well, I don't have a link for it, but he just told me that you can find them on eBay for like $18.
That's pretty cool.
Yeah, so if I can do that, that's even better. What's also
So I'm doing an interesting project like that right now on my Delta. It's running a ramp 1.4, which is interesting that it has two separate circuits. One that's running just the bed, basically. It just takes inputs straight to the bed MOSFET, out to the bed. The rest of it, all the stepper motors, all the logic, power regulators, all that runs off of the other half. So you can actually run ramps 1.4 on 2 different power supplies, and it doesn't care. There are some people who have done cool tricks like running ramps on 12 volts for everything and like 24 volts for a really beefy bed. But what I'm doing, I'm running a silent build. I've replaced the drivers with like really silent TMC 2100s and actually put them in silent step stick or stealth chop mode, and it actually works with some tweaks, and replacing all the fans with silent ones. But anyway, I found some fanless power supplies, but they are only rated for 10 amps each. See, so that's just enough to run the bed, or just plenty enough to run the electronics, but not both. So luckily, I can have 2 power supplies and run one going straight to the bed and one going straight to the rest of the thing. It's about enough.
It works.
We'll see.
You do what you can to make it work. So Apocalypse Survivor just sent me a link for one.
Hey, cool.
So I will send that off to you right away. Oh, I just lost you, but I'm just pulling up the picture. Yeah, it's $12.99 on eBay.
Nice, not bad.
$19 for shipping, which sounds a little bit high, but okay. So I will send that to you right now. I'm gonna have to minimize this. So, guys, I'm just gonna make him disappear for a second. Don't worry, he's coming back.
Bye.
I haven't disappeared yet. They can still hear you, but I just don't want them to get your information on Facebook here. So
yeah, that's all right. So yeah, another common thing people do is just those aluminum blocky switching power supplies, but those don't have like plugs or anything. So you gotta be careful about those. In fact, so far my console's power supply. Here, I just got the link. Thanks.
Yeah.
My console's power switch so far has been plugging it and unplugging it from the wall, which is really bad of me. I ran it for over a year like that. I should have higher standards than that. I'm an engineer, gosh darn it. But I mean, it's like seriously, I didn't even take the time to like put in a real power switch or removable power cord or anything. It was just like you just unplug it from the wall when you're done.
Well, I just like the odd saying, what is it? One of my friends sent me a picture. He's like, just for engineers, it's like has another engineer throwing a wrench at someone else. It says, "Don't tell me how to do my job." I said, "Yeah, that's anybody in the 3D printing community would say something like that."
Everybody has their own ideas.
Yeah. So this is something that our friend Barrett came up with. So he keyed he built a key idea for this for a holder for the X1 that's on top of here. So he keyed it hoping to give it more support.
Huh. That makes sense.
Apparently, it doesn't give it that much support. There's still a little bit of wiggle in it. I know you can't
Okay.
see it on your screen, but let me see if I can bring it up.
That's all
a
right.
little bit more.
I can imagine what you're saying.
So,
I just lift that up.
see how it wiggles a little?
Yeah, I see it.
Yeah. So I'm telling him, don't worry about it. Well, I'm thinking instead of it, because it has a wiggle that pushes it forward. As it pushes more on the PLA, it's going to strain the PLA and cause it to buckle under it. That's my thinking. That's going to be pushing it too much, and then it's going to go like that. So people can see what I'm talking about with the spot with the holder on top of it. So because the weight of the spools are 1 kilo, what I was telling him is to use little triangles here, here, and here, so that way
Can you show me that?
it gives it the
This
strength,
camera?
so it doesn't tip over like that. It has a little bit more strength holding it a little bit more in place.
Can you show me what he means by the triangles?
So what I mean by triangles, this was my idea. This is coming out of my head. Is where you have the 3. I'm just making sure you can see it. So right here,
Yep.
how they plug in, have 3 triangles on here, 1, 2, and 3, as a way to give it a little bit more strength, so that when it tips, if it wants to tip over, it can't, because those triangles are stopping it from tipping and causing more strain.
Sure. Kind of ribs, or not really ribs, but just like, yeah, that would help.
Yeah, and he was kind of like going, huh? What do you mean? It's like, lots of physics, and this comes from, like, I mean, when I studied auto mechanics and and machinery and how to build an engine, we ran into a lot of times where we had to go, okay, how do we do the support now? And
Yeah.
you'd sit there and stare at
You've
an
got
engine
your
block
critical
for
surfaces, but how do you brace them? How do you back them up? How do you stiffen that whole thing?
yeah, and that was something that was in my high school. I mean, in high school, you're thinking to myself, I'm thinking to myself, like, okay, well, we could use aluminum and steel to build a bracket that would hold the engine, but then we have to figure out how we're going to strengthen the fender. Where would it be attaching to the body? How can we make the body a little bit stronger? So, like, as much as people say, oh, that's mechanics that has nothing to do with engineering, my high school was a little bit more about building
There's
and
quite
about
a bit of overlap.
exactly. There was a lot of lab in auto mechanics, which a lot of people couldn't understand. When I would go into my math classes, I'd be going, okay, so we got to figure out strength equals vibration divided by amount of energy versus flex. And one of my teachers just went, how in the hell did you just calculate that? In auto mechanics, we use this damn equation all the time. And they're like, well, and I remember my teacher looking at me going, that's a little bit more above than what I'm teaching you right now. I went, oh, is it? Because that makes a lot of sense. It's like, I don't know why you're not in the advanced class in mathematics, but I understand why you're not in the advanced class for mathematics.
Yeah.
Learning
Well,
disabilities are kind of
times,
wacky.
What's odd is those equations end up so simple. It's so easy to use them, but the derivation of them is the tricky part.
Yeah.
You have to have a lot of underlying knowledge of the physics of the situation, and sometimes even advanced math techniques, and a lot of calculus to go from one equation to the next. But isn't it odd how a lot of those physical relationships end up being, simple equations that are easy for engineers to work with?
Oh yeah, and it used to surprise my teachers because they're like, I haven't taught you that. But how did you learn it? We use it for mechanics when we're trying to figure out engine size, block engine, and trying to figure out the size of a valve to the size of the piston for to calculate how much gas needs to burn at a rate of oil burns to produce the upstroke and how to produce the downstroke. And my teacher just kind of looked at me and went, oh boy. It's like a 2-to-1 ratio. It was just like, it just all of a sudden just like, I'm looking at him going, I know how to calculate that. It's 32. And teachers like just stopped and looked at me and went, how the heck did you just do that? Well, 32 compound the ratio to, it's just like, this stuff's ingrained in my forehead. In grade 9, we learned all this.
Yeah.
and they're teaching me
Dude,
in
would you
grade
mind tipping
12.
down my camera a bit?
Hmm?
Would you mind tipping down the camera a bit so I
Oh,
can see it again?
sorry.
Yeah, you tipped it over so I could see the object. Yeah, there we go. Thanks.
Yeah. So guys, there's 2 cameras running to give you some information here.
Yeah,
Camera
it's
number
a
1
bit of a
is what
weird
you're
scenario.
seeing me on, and you're seeing him on. For him to be able to see me, and for us to be able to connect this way, I had to go and grab my other webcam and force it to go towards him so I could pull up his video. I don't get it. I don't understand why Facebook does weird things like this, but they do.
Yeah. Well, hopefully next time we do one of these
Hangouts, we'll do it right.
Yeah, guest hangout. Yeah.
Yeah, we'll have
figure it
both
out.
screens running.
Yep.
You know, another
And I'll be
idea
able to
was
after
to
you
bring
guys.
this onto for us to do this on say video to video via Skype was another option.
Yep.
I can do that for Skype, so we're gonna work on this still, guys.
We'll
It's a work
figure
in
it out.
progress.
Yeah.
So
Mhm.
Red Light says hi, by the way.
Oh.
He's watching the stream too. So
Hey,
yeah, I mistook in Minnesota Maker because I know you're in Minnesota. Is that correct? Or
that's right. Yeah, I'm actually in our makerspace right now here in Mankato, where I'm from. So born and raised South Minnesotan. I do the depots. I went down to Indiana last couple weeks, and then Maryland to ERRF. That's the East Coast Rep Rap Festival. For anybody who wasn't there, it was awesome. It was awesome. Totally missed out. But anyway, yeah, and my coworkers at that I went to visit in Indiana were making fun of me for my deep O's, Minnesotan, Mankato. Oh, you betcha.
yeah, like we get hurt on our A's, eh? You hozas.
Oh, hey. Oh, yeah. You betcha.
So you said that since
Uh,
you're in your makerspace, did you want to give us a tour around, or because you said you were thinking of it?
Sure, in a little bit, maybe. I think
Okay.
we've got some people out there working on projects, so
Not a problem. I
wanna interrupt.
understand. Yeah, we don't
Absolutely.
want to disturb them. So Red Light's asking what part of Indiana.
Indy area. I have a friend in Broad Ripple.
Okay, well that helps Red Light. I hope.
Yep.
Yeah, people have good success with Hangouts, but because we're doing this a different way, Hangouts didn't work because he's on a cell phone, computer not working. So
Yeah, usually Hangouts work. I did that on my cell phone a couple times, and it worked great. So I don't know. We're just having gremlins today.
yeah, the Gremlins are out today.
Gremlins are out in full force.
Here's something interesting that I found out about this X1. The lead screw. Okay?
Yeah.
It's
Yeah,
not
look at that.
listed anywhere. It's a threaded rod. That's all it is.
Okay.
Barrett tried
Oh,
to
that's
look for it, and he said all he could find was threaded rod for this type of rod.
I see.
So I don't know.
See.
On the model number on this mortar, I got a part number here. It says lot number is 171028. Could I
Okay.
use that to search out what the model might be?
That wouldn't help too much.
Mm.
Lot number wouldn't be that useful. But is there any other information on there?
Just a lot number and
Usually
a
they'll
set of
have a
other
couple
numbers.
like letters in it.
Yeah, it's like
The other set.
yeah, they're all the same number though.
Bummer.
Yeah.
Okay.
All I can make it, all that it has at the end is like it says it's a 51-24B.
That might be the bit that you need. Yeah, I would search for that. That's on the stepper mode. Yeah, honestly, there's not a whole lot of variance between stepper motors. I mean, there is variance. Don't get me wrong, but nothing like fundamentally, mind blowing or life changing from one stepper motor to the next. It's just degrees of, one might be a little bit higher spec, a little higher made, and sometimes you'll have two that are the same height, and one might have a little more torque than the other. But generally, They all have about the same torque density. You know what I mean by torque density? The longer they are, the more room they have to pack coils and the more torque they can have. For a stepper motor of a given height, they usually have roughly the same. There's not that much variance between them. So they should be pretty comparable to most 1.8 degree steppers in that, size range.
Yeah. And if we were to say we did, now you're saying that we could probably do a hypercube with this, in the sense of changing it to like a mini hypercube. How much more would that take to turn it to a hypercube, do you think?
It depends. So the hypercube is an interesting Core XY implementation that was designed. It's not the ideal Core XY, but it's pretty good. It's the best you can do with the common parts that you can salvage from like an i3 style. So it uses smooth rods and a lot of things that you see in like Chinese clones of the i3. Now, what you're dealing with here is a little bit different set of hardware, so you wouldn't have a whole lot to salvage, so we might need to improvise a little bit. But hey, improvisation is fun. That's where stuff gets fun. We can look at the hardware you got and kind of figure out a different design. I'm trying to think about it. So the interesting thing about this cantilever design is it's really the bare minimum you can do as far as like the number of beams involved. You've got a beam for Z, you've got a beam for X, and you've got a beam for Y, and that's about it.
Very limited.
I mean, there's not much to build a frame with there. That's about as minimal as you can get. That's why it's so cheap, and that's why they can have other components that are actually kind of, halfway decent, which is why it gets decent print quality.
Yeah. So we have a message from Apocalypse Survivor. He's asking you a question. I want to ask you about HBot and belts. Do X and Y?
Oh, gee, that's my trigger word. Oh dear.
We might have just dug ourselves a hole, people. So he wants to ask you about the HBot and belt. Okay. Here's a question.
Okay.
Do X and Y have equals? ? Can A and B still drive a rectangular arrangement that is not a square?
Yes, good question. Okay, HBot. I don't like HBot for a couple reasons. It's not a very good at balancing forces. There are some very real gripes I have with it. Namely, that's one of the poor design decisions that actually sent MakerBot down the hole unintentionally. I can talk about that later, but yes, HBot can be scaled to any size or rectangle you want. You could do like a long, skinny HBot that's real wide and has a super long gantry that only moves like a little bit. Or you could do it the other way. You could have a HBot that's got a really short gantry that moves a long ways. You can scale it to any size or rectangle you want. Any proportion will work just fine. The only thing about it is I wouldn't use HBot. I would use Core XY. The math works out the same. The forces just work much better in a Core XY. So I would say yes, you could use an HBot to scale to any arbitrary size of rectangle, but I would say you probably shouldn't. I mean, you could, but you shouldn't, right? You could do a Core XY with hardly any more hardware, and it solves a lot of problems with the HBot. And a Core XY similarly can be scaled to any proportion of rectangle you want to use.
Now, do we ever come up with the name for your printer, your Core XY that you're working on?
I don't think we did. Okay, I am a total kinematics nerd. I love looking at different types of mechanisms and belt arrangements and rails and things, and all sorts of parallel especially ways to make stuff move. I just really get a kick out of that, especially really lightweight mechanisms that are simple to build and maybe just interesting to look at. Who knows? So a while ago, I worked on a mechanism it's like Core XY, but it's in a T shape. It's a cantilever gantry. That works with the same math that drives a Core XY. I think we're kind of talking about calling it like Core XY T or T Core XY or T Core or something. We're working on it.
X to the Y minus a T? X to the Y minus a Z, Yeah. Go into some rap mode,
Yeah.
X to the Y minus a Z, you know.
Yeah. So we'll
But
see. I didn't come up with a name for that yet.
yeah, well, like I said, that's going. We're getting off topic. That one, but
Yeah.
it just made me realize
Stuff's
that.
fun, isn't it?
Hang on, did we name it or we didn't come up with a name? You know, but
Yeah.
yeah, like everyone here, as I'm talking to you guys right now, thanks for being 6 viewers, guys. If you guys want to tweet this out, let everyone know we got Daniel on the Print Whisperer. You know, if you want to say the Print Whisperer at Earth, because that's what he was doing. He was running around helping everybody with their printers. I feel sorry for
Probably
Geek Tech
shot,
with their printer.
half a dozen. Got half a dozen printers working. So.
Yeah, which was good because I don't know what happened at Earth, but it seemed like everybody's printer was failing.
Oh yeah. Oh, tell me about it. It was like everybody was having gremlins. We had you saw our big tool changing printer, right?
Yeah.
Our big aluminum fridge.
Bertha, as I like to call it.
Gamma.
I know it's called BAP, but I like to call her Big Bertha.
That's a good name too. We're working on servos. So XY are not driven by steppers. They take stepper signals, but they're servo motors instead. So they're completely closed loop. They keep track of where they're supposed to be. And whereas a stepper motor could accidentally skip over a couple steps, and the board wouldn't know the difference, it would just keep printing it blindly, just shift it over, and your print is ruined, and it doesn't know. A servo will keep track of that and correct itself and apply forces when necessary to make sure that it's where it's supposed to be. Now the problem is these servos don't take in quite exactly the same type of signals that the Duet is sending out. So I had to do some little bit of electrical mumbo jumbo. It wasn't even like on the Duet forums. Nobody's ever really done this, so it's kind of something I've been working on for a couple months. And I finally got it to work, but not at Earth. Like the E3D guys came over, and Sanjay was like, "Can I see it run?" And I was like, "Sure, I'll give it a shot." And it didn't run. It didn't run at all. I felt so bad.
Don't feel too bad because I mean a lot of us were just having issues. Like I don't know what was going on, but every time I got the CR10 to finally start printing, it came out in crap. I was like going, why won't you work for me today? It's like, I want to strangle you because you were working. I had it working. When we got there. Turned it on. Everything was printing perfectly. The next day, the gremlins came in and
Yep. Same for us. I mean, we had it. I was doing travel moves at 1.5 meters per second on the big thing. 1,500 millimeters per second is really fast. And the next day, it was traveling at a big whopping 0.
Yeah.
It wasn't doing anything.
Hey, get this. John wants to go with you next year to Earth.
Yeah.
So
we should do Murph. We should do Earth. We'll hit up all of them.
Yeah.
Hopefully there's more. I'm loving these printer festivals. They're fun.
Here's what we got so far. Apocalypse Survivor said, "Can you discuss the difference between the HBot, T-Bot, and Core XY?"
Yes.
Red Light's asking you
so
that.
Fun. That's right up my alley.
Okay. Red Light would like you to know that next time you go to Indy, stop by Komokomo, which I believe is where Red Light's from.
Sure.
Craig's 3D printing space. Thanks for jumping in, buddy. I know who you are. So this is Dangle. We call him the
Howdy.
The print expert of the bunch. He's helped me a lot of times with my printer, so he's been very helpful. So let you go on. HBot, T-Bot, Core XY, differences and
what's the difference?
Yeah, and get to that.
Okay. So an HBot is a very interesting, very slick, it's a beautiful mechanism. Just looking at it, it looks great. Okay, you got your rails and you got a gantry that connects them. And there's just one continuous belt looping around tracing the shape of an H. It looks awesome. You can make some really nice hardware implementations of it. Problem is, the way that the forces add up when you sum up all the tensions on the belts, under certain types of movement, namely whenever forces are experienced left to right on the gantry, you notice that the tensions of the belts exert a net twisting force that yanks the gantry like this, like a steering wheel. And that's a problem. Frankly, that's a big problem. It's not something you can just solve with software. The only fix for it is to totally overbuild your hardware and keep your forces low. Keep your acceleration force is low. Now, on these types of machines, I like to make a distinction here. We're dealing with machines with low tool head loads. So, Ron, do you know what I mean by a tool head load versus an inertial load?
No, I do not. Unfortunately, my knowledge is limited, but as I've gotten more into this, I don't know all the initial mathematics. I'm going with mathematics I've learned a long time ago, so I do apologize about that.
Sure. Well, let's start here. So, in some types of machines, like CNC machines, or in machines where you're working on, maybe you're mixing something, or you're moving something, or you're pushing something, or you're milling or grinding something, you have something called, a tool head load, where your end effector, your hand or your object or whatever you're moving, has a tool on it, and you're pushing at something, or something is pushing back on you. That's a steady force that's usually applied at a steady feed rate. So you're just pushing, and it's just pushing back at you, and you're just kind of steadily moving it and getting work done. Maybe you're removing chips from something, or who knows what it is. 3D printing is not like that. 3D printing and some other types of robots, like pick-and-place robots, have no tool head loads. Basically, there's no drag on the nozzle. Ideally, when the nozzle is moving around, as long as you're not like bumping over overhangs that are curling or something, there's really no load on it. All you're dealing with for load is like resistance, like friction in the bearings, which should be basically nothing. I mean, let's be realistic. If it's nicely oiled and everything is square and you're not getting any binding, this is like really no force at all to keep it moving. It's just like coasting, right? The only forces that it ever sees that are significant are when it's accelerating or decelerating. So when it encounters a corner and it stops, that takes a force. And when it accelerates off in the next direction, that takes another force. That is what I mean by an inertial load. So you guys all remember F equals ma, right? So this is where the physics come in. We want to keep those forces low. So on an H-bot, the racking forces, that's what they call it when that gantry, that makes the center of the H, gets yanked left and right, which screws up things and wears out hardware and messes up your position and stuff. We want to keep that from happening. So that means we need to keep the forces low. Now we have two options. F equals ma. We can make the mass low, as low as possible, and say you've already done that. What can you do? All you can do is decrease acceleration. That's the only thing you can do left to keep the forces low. If your bearings are already oiled and your mass is already as low as you can get, then really the only thing that you have left to do is just decrease your acceleration. And the problem with that, as everybody who drives a car knows, is the lower your acceleration, the longer it's going to take you to get up to the speed you want. And the lower your acceleration, the longer it's going to take you to get back down to zero. So we have a MakerBot 5th Gen in the other room, and that's an H-bot. It's running such low acceleration, you can hear it. It goes, whew, whew, whew. It doesn't really even ever get up to top speed in a lot of these short travel moves. Even in something this size, it might not even get up to like 150 millimeters per second, which I guess by my standards is pretty low.
Yeah.
I've been working with 1.5 meters per second, but yeah. So that's the problem with H-bot.
Everything looks slow after 1.5.
You have low accelerations, so your prints are pretty long. Everything just takes longer. You want accelerations to be nice and short and snappy. That helps with a lot of aspects of the print. And H-bot, fundamentally, because of the way that the gantry can't tolerate high forces, requires you to have really, really low accelerations, which is a bummer because H-bot looks really nice. It's light and it should be fast. It would be totally capable of a high top speed. It's just that it can't tolerate high accelerations because it can't tolerate high forces.
Could it be the braking? Like, okay, I'm going back to my mathematics here of auto mechanics, from stop to go to braking inertia from brakes here. So if it takes force equals mass equals acceleration equals
force equals mass.
Yeah. Sorry.
Yep. F equals ma. Yep.
Yeah. Braking, we know, is required to the amount of pressure that you put on the brake to the amount of pressure that's down through that the fluid has to travel to push on the caliper to apply the pressure to the discs.
Mm-hmm.
Could it be that because on the H-bot, I'm thinking, if it can't run that fast, then why would that be beneficial to use if it doesn't allow you to have the speed and acceleration?
It's kind of not. It's frankly, that's the problem. It's really not that beneficial to use. It should be, because it looks light and all the components add up to a nice small bill of materials. It's easy to build. It's easy to put together. It's easy to write a bill of materials for. It's cheap to make, but it just the way the forces line up, it just can't tolerate a high, like you said, a high braking force or starting force.
Yeah, sorry, I'm just catching up on something here that just sent to me. Also, Craig is upset with you right now because you don't have a YouTube channel. And he goes, "What? Blasphemy!" Just kidding. Twitter. So he wants to talk to you. So do you have a Twitter account by any chance?
Yeah, I do have Twitter. Twitter. Right. Hit me up on Twitter. Techie Fiddler. That's my username on pretty much everything. So find me Techie Fiddler. Techie Fiddler is spelled just like you think. TECHYFIDDLER. You can find me there on Twitter, Facebook, Fortnite, Minecraft, whatever.
Fortnite. I didn't know you played Fortnite. Okay.
Yeah, a little. I dabble. I'm no good at it at all. I'm a catter. I'm not a gamer.
Heck,
Who am I kidding?
My third game in Fortnite, I got killed by one and only Ninja, who's known on Twitter.
Really?
Yeah.
Oh, that's an honor.
He came up behind me, shot me in the back, and took off. He's like, "Did I just shoot a newbie?" And so I said, "Yeah, we were watching." Then everybody found me on the stream over there. He comes in, finds my my Twitch handle, when it said, "Sorry, man, I didn't mean to hit you. I didn't mean to hit you. I didn't know you're a newbie. You're just learning this." I said, "Yeah, okay. Unfortunately, I'm not great at." And I said, "I'm not great at first-person shooters." He goes, "For a newbie, you didn't do too bad. You kept on missing. I kept on trying to hit you. You kept on missing my hits, which was good. You know how to dodge, but."
Hey, that's good.
He's like, "But you had no weapons." So, I said, "I got in the game. I landed in an area with no weapons. All I had was logs." It's like, you didn't do too bad for a beginner, but it's like,
materials.
You land in an area where you have all material, no gun. That does not help. I mean, no, it does not.
Doesn't help. No.
So, going on here, it says, let's see. John Mack says no direct drive and very light-headed, light tool head. Okay.
Sure. Yeah. So suppose you have like a Bowden tool head, super light. Let's say you've done the absolute lightest thing possible. You've done like a single, like a E3D V6, which is not like the lightest hot out there, but it's among that. And suppose you don't even have like a part cooler, like a fan on there. Suppose you do like a remote, like a bird air pump, a little air pump mounted off to the side, and then it pumps air through a hose, and it's got a little ring that surrounds the nozzle and blows out through there. Super duper light. I mean, just like absolute bare minimum. If you've got a moving carriage that is bare minimum, I mean, absolutely stripped down to the smallest possible force, you could get it maybe down to, let's say 50 grams, 100 grams, I don't know, somewhere in that ballpark.
Okay.
Because you're also moving the slider, right? On like a linear rail would be like the minimum moving weight, and you're gonna have a little printed part to tie it all together. Let's say you've got 100 grams. Would be a decent roundabout estimate. If you want to accelerate that fast in X, what you got to do is, so you got to think, what is this being compared to? Let's say you have a light direct drive, maybe 250 grams. If this is 100 grams now, and you shaved off, 60% of the weight, now you're at 40% of the weight, that means you can accelerate, I need a calculator, but that's on my phone.
Well, let's say
let's say it's 200. You shave half the weight. That makes it easy. Okay, I can do that in my head. Let's say you had a 200 gram setup before, and now you've shaved out half that weight, which is pretty astounding and a great achievement. That means you can now get twice the acceleration and get the same amount of racking as before. Now, twice the acceleration means
twice the amount for a force to stop.
Yeah, that's great. Only problem with that is, if you were to just build a Core XY in the first place, you could have been hitting those numbers anyway
without having
the heavy carriage.
Yeah.
You could have been hitting those numbers with the 200 gram carriage anyway. If your Y was capable of sustaining that force anyway, then you could have been doing that in the first place with the heavy carriage. So, why not use Core XY? Because you could be running a light direct drive, and Anyway,
Yeah, that makes sense. I mean,
so yeah, if you have the weight, then yeah, you can double your acceleration and keep the force the same. So
yeah. Here's a good question then. So, what's the difference between the T then with the Core XY then?
great question. So let's look at a couple things. An H-bot, right? So you've got two motors, both mounted on the frame, and you've got two parallel rails that are sitting at the edges of your frame, and you've got a gantry that connects them. And you just wind a single belt around all that, and it looks like an H. Now, if you arrange it differently, some of you guys might have seen photos or videos of something called a drawbot. This is a type of T-gantry, or a T-bot. T-bot and T-gantry are synonymous. This was common in the pick-and-place industry until Deltas really kind of came on the scene with processing power getting so cheap. Deltas now have kind of taken over pick-and-place. But these used to be common. You could mount them over a conveyor belt, and instead of having like an H-bot does, they have a rail and a rail mounted on a frame, a gantry between them. They just have one big rail and then another rail that comes over, and this rail is able to move like this and like this.
Oh, okay.
It's kinematically, it works out to the same thing. You have a motor on the frame and a motor on the frame, and you've got a fixed carriage, or not fixed carriage, a fixed rail, and then you've got a beam that's like a gantry, except this one moves in X and Y.
Oh, okay.
Yeah, they're pretty funky. Then you just wind the belt around the whole thing, and it forms a T shape, or more like a plus. But depending on where the gantry is, it could be like a T or a T or a T. Or...
Yeah, I think it's now
So
T.
those-
I think it's now T is what's being used on the new version of the MakerBots.
no, that's HBot still.
It's still HBot, okay? Because I
Yep,
thought
right.
I saw it doing the T thing last time.
No, still HBot.
Okay.
Hopefully they switch to Core XY or something better. But so T-bot or T-gantry, same thing, is pretty cool. Again, it's a really neat looking mechanism. I mean, they look slick. They got your motors mounted on the frame. They're really lightweight. But there are some problems with them. One problem is that the center of gravity shifts. If you were to use one of those in a printer, and I have seen a couple of rep style things that use them, they have an arm like that. And the problem is that if it's sticking all the way out and your hot end is way on here, it tips that way. And if it's back, it tips the other way. So it's like your forces aren't balanced. And depending on which way it's sticking, it's going to have inertia point in different directions. And it's just like, it's difficult to brace because the forces are always coming from different directions. You don't know whether you're trying to push against something that's preloaded down or up, or, it's difficult to brace against because the forces are always changing directions. Now, same thing can be applied. You can just lower the moving masses and lower the accelerations, and that keeps the forces down. And then once the inertial forces are low, relative to the stiffness of the gantry, it'll work just fine. The problem is in 3D printing, we want those accelerations to be as high as possible, as long as your hardware can support it, of course, because we want to get our prints done nice and crisp and fast. So T-gantry isn't really great for that either. But as far as Core XY goes, now Core XY, it's like HBot, but not quite. Core XY, I found myself looking at this going, okay, so Core XY, we have the same type of system. We got two rails.
Give me 1 second here.
Okay.
So right now we just have, hey everybody, Chris Riley's in the house. So everybody understands what that means. I mean, if you see my video from Earth, all of a sudden you have, if you saw any time wherever Funking was there and he runs into Chris, hey everybody, look, it's Chris Riley in Chris Riley's basement. It's just like going, oh yeah, hi everyone. So Chris Riley says he has a lot of questions here. So
all right. Let's
Craig just say Chris Riley's my hero. Oh, he has a man crush. Everybody man crushes on Chris. And Chris, just let you know that that purple thing right there in the corner of the screen.
Hanging up there.
Yep. That's your magnet, buddy. So yay, Chris Riley. Yeah. Hopefully Chris knows what I'm talking about. Hopefully they got back in touch with you. If they didn't, let me know personally, and I will go and talk to them and see if I can get Ron to contact you back. Okay. So just saying that out of the goodness of my heart, because I want to get that taken care of for you. Okay. So Chris Riley said he had a question, so he hasn't really said anything yet. So I'm waiting for him to come up with his question. Just go back Apparently, John DiCaprio says PUBG is greater than is better than Fortnite.
Fortnite. Oh boy.
Yeah.
The next greatest debate: Mac, PC, HBot, Core XY. Well, there's no debate there.
No.
PUBG versus
The
Fortnite.
the
Okay. All right, we'll keep that on.
the ultimate
No politics.
conversation is what's better, Super Nintendo or Sega Genesis.
Oh man, that's before my time. I'm probably showing my age there, but
I have
that's
to give
before
it
my
to
time.
Oh jeez, I have to give it over to the Super NES. But when it comes to, you know, Xbox versus PlayStation, oh, so close to each other.
There's another good debate. Yeah.
I have to go Xbox over PlayStation 2, but PlayStation 3 over the Xbox 360. But there were just some games on the Xbox 360 that were just phenomenal. You know, just saying. I'm sorry. I could not afford a PS3 when it first came out. $900 was just stupid. Okay. Go ahead. He says he likes what you were explaining to keep going on the Core XY explanation. So they want you to keep on going about this.
Sure. I love this stuff. I wish I had a whiteboard or something. Maybe I should get a YouTube channel. I could annotate this stuff out.
I've been telling you since day one.
I know.
You get the YouTube channel.
Telling me I need to get the YouTube channel.
I will bring the Country Network in. I'll bring the Country Club with you. I will bring Chris Riley and his people in there. We'll have to get Fun King on here one day and just have Fun King just talk with him, and that would be an interesting conversation to see.
That would be fun.
Yeah, so
we should do more of these group chats between all these people. It'd be fun to stream that.
Here's one thing I want to do with you guys, and just, you know, since you guys are on the channel right now, tell me, does this sound like something you would like to have? A one-on-one conversation with Daniel, online, live. Someone in the room gets drawn a name. I will send you a message over whichever way I can privately, and I'll give you the code to come in the room. And then you can ask your question. Once your question is answered, then I will kick you out of the room, and then we can take another question live one-on-one. It's a great way for everyone to grow their channel. It's a great way for us to communicate with you guys. And if this is something you guys would like to see, let me know in the comments down below. Comment on this video. Thumb up the video since you guys are all in here. We got like about 9 or 10 viewers in here. So guys, start hitting that thumbs up button and start showing some love. But let's get back into the Core XY. So
yeah, I'm just thinking about what that would be like. You know, you could have, you know, people doing like show and tell, or, you know, 3D printer troubleshooting. We could kind of show what sort of problems we're working on or what designs we're working on, just kind of share back and forth, and that'd be a lot of fun.
Yeah.
Anyway, back to the Core XY stuff. Yeah. Well, sorry to steamroll you there. So Core XY. Core XY looks kind of similar to HBot at first glance. I mean, it's a gantry. You got a rail on one side and a rail on the other, and you have a gantry connecting the two. And you also have your motors mounted up on the frame. Also, weirdly enough, the math works out the same way. So you can explain the math a lot of different ways. One way to explain it is mapping. So you can look at it as like a vector function. You could say, you know, one motor maps to like a angle 45-degree coordinate type of system. The other motor maps to the opposite, and you do vector projections of the two, and like that's how you figure out your coordinates and your Jacobian matrices and stuff. Another way you can figure it out is just like add and subtract the two. If you want to figure out what your x coordinate is, you add the A motor plus B motor. If you want to figure out the y coordinate, you subtract A motor minus B motor. Like that's another way to do it. But it's the same for HBot, GBot, Core XY, and then I was looking at those going, wait a minute. If you take HBot and you flip it inside out, like you take the two rails, right, and each one has a motor on it, and you like superimpose those, and you stick the gantry off of that, it like turns into a T-bot. I was like, Core XY, what if you do the same type of transformation to that? You have a rail, you have a motor on both. You should be able to do the same type of thing, turn that into some kind of cantilever. You should be able to, you know, flip the kinematics, flip the belt run inside out, and turn it into some kind of gantry that's like cantilevered sticking out there like a T. But what does that look like? And it took me like a whole afternoon of just like caffeine-fueled whiteboarding. Just, I can't figure out these belt runs. And I eventually figured it out in October of 2016. Have been kind of working on a rep wrap using that design ever since. And is a lot like, how the HBot and T-bot are related. It's, so CoreXY has two belts, right? It's not like HBot where it's got one. CoreXY has two belts. One loop constrains the hot end, or the end effector, I should say, in one diagonal, and the other loop is responsible, the other motors on the other loop, for constraining it in the other diagonal. And there are different ways to run it. One way that's really common because it makes building it easy is to use them on separate planes. So you've got one belt run with one motor that moves in, the XY plane, and it's like flat here. And the next might even share some of the same axles on some of the same idler pulleys, but it's just offset up a little bit. Not too much wrong with that. I mean, it's a good, easy way to build it, but the forces are like a little unbalanced up top, so it can be a little like tippy, but it's not bad. It's way better than HBot, because on HBot, your lever arm, you guys know about lever arm, right? Like if you're trying to unstick a really stuck lug nut, you go for the long wrench. You don't go for the short one, because that multiplies your torque. Problem with an HBot is the imbalance is being applied over the entire gantry, really long lever arm, so you have a lot of torque on it. On a CoreXY with the two belt plane system, they're really like right on top of each other. Your lever arm is tiny. Any imbalances are almost negligible. I say almost because they might cause issues once in a while in like a really weird build, but anyway. In the average build, it's not a problem. It's a pretty slick system. The other way of doing CoreXY is a bit more complicated. It involves a crossing. You need to have, if you want the belt systems in plane, you need to have them switch over because some need to be inside and some need to be outside, and they need to swap places. So I could show you a neat way to do that in a bit. But when I was developing that T gantry, the version of CoreXY that's like that, I decided to just do it easy, do it with the two-plane system, because it was just blundering my brain trying to get them to be in the same plane. It's not that big of an issue. So it's got two T-shaped belt runs that are superimposed on top of each other using a lot of the same pulley axles and everything. It's really a pretty slick mechanism. I could maybe send you guys some pictures of that later if you're interested. Actually, yeah, follow me on Twitter. I'll tweet about it.
There you go, guys. Follow him on Twitter.
There you go.
We'll put the I'll get his Twitter handle off of him again later. But it's Techie Fiddler right now, correct?
Yeah, okay. Techie Fiddler.
Everybody, Techie Fiddler.
Techie, and I fiddle. I play bluegrass fiddle, so Techie Fiddler.
Yeah, so I'm just reading some stuff here. So right now, Askewed Viewed 3D, aka Shroom, is designing shields for John and Ken's channel, which is really cool. And then all of a sudden I get it, and then it said the other one's going to be for my channel. So thank you so much. I do appreciate it. But we're going to, but guys, does Daniel need his own channel? Please let me know, and I will, and we'll force him to get his own YouTube channel if you guys think he needs one.
Against my will.
Against his own will. That's right. We are going to make it. We're going to force it towards him. Thank you, Apocalypse. Apocalypse, that's why you got a wrench, buddy, because you always help me out here. You just posted your Twitter information on the site, so everybody can now click on it and sign up.
Yeah.
Yep. And if you are signing up, tell them you should put in, I'm now following Techie Fiddler thanks to Canadian Maker Project, and then link the YouTube address. So people go over here and see what we're talking about. That's not a bad idea. So, guys, if you want to put that out, that'd be awesome. If you're on Twitter and you're going to follow him, say, I'm following because of Bump Pound CMP, and then the YouTube Pound YouTube, Pound, then the, sorry, should be, I'm following because of the YouTube link, then CMP, then Pound, 3D printers, and all the other hashtags we need. But if you put Pound CMP, then I can go back and review all the comments, and I can pass it on to Daniel, and he can easily follow it too, because then Pound CMP, he knows to do that on Twitter also.
Easy to sort stuff.
Exactly.
Yep. When you're hashtag CMP, it's easy.
Yeah. Canadian Maker Project, which works. It allows us to track everything. But like I said, guys, we are doing a T-shirt thing. I'm hoping to have a video up on Wednesday to talk about it. It's going to be Thursday afternoon between the hours of 1 p.m. to maybe 3 p.m. I'm still working on the hour thing here. But I can already tell you there are 3 people that are now getting a T-shirt. So one will be going to you, Daniel.
Sign me up.
Yeah.
I want one of those too.
Okay. So, well, I'll see what I can do about sending you one for free.
Well, you don't have to do that.
Country I know wants one. He told me what size to get him, so that's easy enough to do. And then the third person is going to be the one who's going to win, is going to get the T-shirt. So remember, you have to be on the channel that day and be chatting, because if you're not on the channel, how's the bot going to know when to pick your name? Just saying. But yeah, going back to a Core XY, like the advantages of that, it runs on 2 pulleys. Or 2, I should say 2.
2 different belts, yeah.
Yeah, 2 different belts. What about crossing? Like, how does the head cross from one belt to the other belt? That's the one thing I've always found a little bit funky about the design.
All right, well, we're about to try something. Is that still upside down?
Yeah,
okay.
Was.
I'm going to try something. The Wi-Fi gets a little hairy in our printer room, but I have a printer with me, the big one. Brought it up to Minnesota, that's right. And it's got a pretty neat example of the belt crossing in it.
Okay.
All right. Well, let's see if the Wi-Fi holds. Would you like it if I showed you guys that belt crossing?
I think
we were talking to Bill Steele, and he was pretty ecstatic about. It solves a lot of the problems with Core XYs. It's, if I do say so myself, a pretty slick implementation. So.
I think we should show it to them, because even though some of the people may have not seen it at Earth, they can see this big, huge monster now.
All right. I'll just turn on the lights in here. How's the Wi-Fi looking?
Wi-Fi is still standing up steady.
All right. Well, here's our MakerBot. Having some issues, but I'll grab it. Here's an HBot. Motor back here, and the belt run goes like this. Nice belts too. They're like 9mm, maybe genuine gates, probably Kevlar reinforced. They're really, really good belts. But the belt run is very long, so because of that, there's a little bit of bounce. And yeah, here's the whole extruder assembly. Here's one of the other problems with this. Because it's MakerBot and they're concerned about their public image, it's got to look nice and it's got to be protected from everything. These are carrying around quite a bit of weight. Remember what I said about F equals ma, right? If you want to reduce the racking forces, you got to reduce the mass and the acceleration.
Yep.
Well, they're lugging around quite a bit of mass, so unfortunately that means their acceleration's got to be really low. So prints take quite a while. But all right, here's our big one.
There's the bat,
guys all see
or
that?
otherwise known as I like to call it, Big Bertha.
Yep. So these are ClearPath NEMA 23 drop-ins. They're not steppers. They're servos. They just drop into the same form factor as a NEMA 23 stepper. That little voltage converter board I was working on. They pull their signals right off of the board. The Duet we're using. Breakout board here. So this is the Duet Wi-Fi, and this is the UX5. We're using all 10 stepper driver channels on this thing. It's pretty insane. But anyway, so I should show you our motion system. So what we have here is MGN 15 rail. This is a genuine Highwind. Same on the other side. And we've got a gantry crossing between the two. This is an MGN 12 rail, and it's mounted on some of the bolt holes right on that carriage. Now, one thing you might notice about that is it's upside down. If you look real close, you can see that carriage is upside down. That's because the rail's upside down. That's all right. These things really don't mind much being run in any orientation. That's a pretty minor load compared to the loads that they're rated to take, so that's okay. Next up, you might notice, well, this isn't a Core XY. What's wrong with this? In a Core XY, isn't your gantry supposed to go left to right? Your gantry is going up and down. What's the deal with that? This is just like turned sideways. And yeah, it is turned sideways because we found that as we're working on this machine, my buddies in Indiana, and that's Art3 is our nickname. Additive Research Technologies is our real name. We have a Twitter too. You can follow us there. We found, people like horizontal, like landscape type
People don't like portrait mode. People like landscape. That's the way they want their printers to be arranged. So we wanted a lot of print area, but we wanted to keep that gantry short. So yeah, we just flipped it sideways. Nothing wrong with that. The kinematics still work out just fine. So no hot end on here right now. It's because we're cooking up some tool changer stuff. But anyway, Core XY, 2 belts, right? You got one belt that runs around this motor. It runs around the back side and runs over here. And then you've got another belt that runs around that back motor over there. You see that big servo, and then it runs around. And if you count up the ends on the carriage, you can see there are 4 belt ends. So yeah, if you count them up, you can see, there are 2 distinct belts, and all of the ends terminate on this end effector. So that's a little different than HBOT already, because on HBOT there's only 1 belt, and it begins and ends on here, and the other side just passes through. So you can tell already this is not an HBOT. But anyway, now the secret sauce. This particular implementation of Core XY has a couple really neat tricks up its sleeve. One second. Yeah, I'll close it down a little bit. All right. I'm just going to close down the makerspace a little bit. So once we're done streaming here. So this Core XY implementation has a couple tricks up its sleeve. One, if you look at those belts, and they're nice and loose right now because I was shipping it, so didn't want too much force on it. So I can kind of pull them around and you can see them better in this light. They are basically centered right on top of that rail, and really good as well. So that means the forces are really, really close to the rail. The tension forces pulling this carriage are really close to the rail, which is good. That means the lever arm is really short. There's not a lot of tipping going on. It means the forces are really direct. So I like that. That's good from a mechanical engineering standpoint. The next trick up its sleeve, which you can actually see on this. This belt piece, the one that drives this carriage, is directly centered over the rail, the MGN15 rail. Now that's the part. This is actually a little different than this. These are 2 different sections. Those are the ones that impart the left-right forces to the whole gantry. And they are centered over that rail, which means the forces are also likewise centered on that rail. So again, balanced forces, really, really nice. Then the final piece of coolness, Jacob Ayers, he's on Twitter too, although he doesn't do much on there. He was responsible for this. Really cool guy. You should talk to him about drafting. He's real smart. This is the cool part that I did. Anyway, in any motion system, you need all of your active sections of belt. You know what I mean? The sections of belt that might encounter a pulley. You want it all to be planar, so that as this belt goes straight and goes wherever it goes, the lengths are not going to change. So you want from where the belt leaves this pulley to where the belt picks up on the pulley in here, you want that to be exactly parallel to the rail. Because if it's twisted or bent or anything, it might change lengths very slightly if you do the trig on it. The trigonometry, you find the belt length changes, which means your tension changes. And that's no good, especially on a Core XY. So that belt run right here is beautifully straight. Every piece of belt that touches any of the pulleys on this gantry is completely planar, which is what counts. And in this mechanism, there are only 2 pulleys that are not part of the moving mechanism. That's this one here and this one back here. Those 2 pulleys, it turns out, you are free to move up and down a little bit. So what I did was drop this one by 1.5 millimeters and raise this one by 1.5 millimeters. And that allows us to somersault these 2 belts past each other. You can see an air gap between them. They each take a half twist, and that is what allows the 2 belts to go past each other. On this
they're
side,
not rubbing or anything like that, correct?
Nope. The just kiss right past each other. There's an air gap between them at all times.
Oh, wow.
And it's almost planar. I mean, and it's just this pulley and this pulley. Like I said, everything else, every pulley that matters is completely planar. It's only those 2 off on the sides that are just slightly out of plane, which is okay. There's really nothing wrong with that in the design. So that's how you can get this belt to be inside here, and over here to be the outside one. Which brings it over to that motor. It gets the belts where they need to go in the CoreXY system. It's a pretty slick little just somersault where the belts just switch places. Very flat, very compact, slick.
Yeah, don't get me wrong here. I'm just replying to someone. Someone's leaving already, so I'm just saying bye to everybody.
All right.
Yeah. So yeah, guys. So what did you think of that? Seeing that
I'm getting some new Twitter followers.
Machine. Oh, you're getting some Twitter followers. Oh, that's great to hear.
Yeah.
Yeah. So no, I'm not leaving yet, guys. But Daniel's gonna have to leave soon. Unfortunately, he has to close up shop today. Correct?
Mm-hmm. Yep, it'll be a little while. I got maybe about half an hour.
Oh, okay. So, got a question for you about the about enclosure, because this is something I was just thinking about just going out through the day today. Now, if you're doing ABS, and I was thinking about building an enclosure using fiberglass was one idea, or acrylic, but then I thought, well, maybe the heat might be too much for that type of glass. Would it be or no?
For the glass, oh yeah, that'll be fine. That'll be just fine. Yeah, really, it doesn't matter too much. Fiberglass, acrylic, really, all of that can handle the temperatures we're working with just fine. Yeah, I wouldn't worry too much about that.
Yeah, because
what I would worry about are the parts inside. If you've got, say, do any of the stepper motors get warm? Because in an enclosure they will get warmer. And if you've got acrylic in there and it gets really, really hot, like inside the enclosure, maybe it'll get a little warm. Printed parts, especially, be careful with the printed parts.
Yeah.
And electronics.
Oh, I know. I keep the the enclosure I'm building is for the CR10. The idea I was having is have two fans, like probably 120 millimeter fans that are computer based, blowing up air from the bottom so it can actually circulate air within. Have some air vents so air can go in and out. Attach a hose to the top to push the air out so it can capture the toxins or whatever. I'll have to figure out how I'm going to do that. But at the same part, it's going to be, hang on. Chris, this is why I interviewed them at Murph, because it was such a different machine. If you go watch my video at Murph, I was talking with Jacob where he was sitting on top of the printer. And they was both you and Jacob were sitting on the printer, weren't you?
I think so. It was a good interview too. I watched that. That was a nice interview.
Oh, thank you so much. Unfortunately, now we got a new problem with my camera, which we found out there is a gremlin in my camera. We're just trying to fix that gremlin now. We think we figured out where the problem is, why I didn't have mic audio. We think we figured it out because I went and did another event, no audio this time. I have nothing. But I did connect Jacob with a company, with a university that's down here in Toronto, which is interested in what he is working on right now, that map that we were that he was showing me. The Braille map.
Yeah.
They want to talk to him. So he might have some more work, or maybe get some more leads on work, and who knows what's going to happen. But yeah, everybody's saying, thanks for the close up. Chris Riley says, thanks to Daniel, great info. Have you been to an event? Not sure why I haven't talked. Chris, you're busy. It happens. We all got busy. I mean, Daniel was helping out the guys over at Slice Engineering, which you guys have all watched from Country's stream about what Slice is doing and how their technology is. Slice technology is just interesting.
It's head and shoulders above any other hot end I've seen. The thermal engineering, it is just fantastic. Little side note, my day job, I'm an HVAC engineer, so I spend all day working with airflows and heat transfer. So exactly the same things you see in a hot end.
Well, Craig works in air conditioning.
It's a little different, but I guess I have the tools to evaluate hot ends, and those hot ends are awesome.
Yeah.
Best I've ever seen.
Now, here's something that I wanna convey over here with everybody, because I've heard this 1,000 times, and actually, I had it confirmed with Daniel, and he agrees with me. CR10, the Fang is not that great of a blower compared to the stock you were saying with the CR10.
Yeah. Yeah. Is this a question we're having in the comments here, or
I've been
is
seeing
this just like
I've been
a
seeing
general
people
thing?
tell me all the time, put a Fang on there. No, keep your stock cooler. No, put a Fang on there. Put a stock and I'm just going, the stock cooler works. Why would I want to go to a Fang? And you're saying
Sure.
there's not a lot of um like you were saying you don't like the Fang.
The Fang has some benefits. The one that I don't like as much is the ones that like circle around like the DIII cooler. That's the one that I don't like as much.
Okay.
The Fang has some benefits, but honestly, the stock cooler, yeah, it's not that bad, really. It's pretty good. You want me to talk about that some? Because yeah, airflow, I like talking about that too.
Let's talk about that then.
Sure. So there are two parts to this question, right? We want to remove heat from the freshly deposited plastic so it solidifies, right? And there are two parts to that. One is just the raw amount of airflow we're moving over it. You know, the faster you can wick air over it, obviously the faster it's going to cool it down. So fan size and fan power will play into that. And then the second part that plays into it is how effectively is that airflow leaving the vicinity? You know, because if you're blowing a ton of air but it's just like backing up and a lot of the air is actually just going around and not really flowing over the plastic that was just deposited, well, that's not a very efficient cooler, is it? So there are two aspects to this. One is the fan power, and then two is where the air is getting directed. Now, the stock cooler is a pretty small fan, right? Is it like a 40 millimeter or 35 millimeter maybe?
I think it's like 35, if I remember
I think it's
correctly.
35.
Yeah.
I started using a couple of those on my Delta before the CR10 came onto the scene, and they were pretty hard to find, and now they're much more common, so I think that's it. Yeah, not a lot of horsepower in that thing. It's a pretty small fan, pretty small blade area, pretty small input, you know, so pretty low airflow, just raw CFM, pretty low airflow compared to like a 5015 fan. You guys know the 5015, that's what's on most of the Fangs. It's that big one with the iconic shape, and it's, you know, 50 millimeters wide basically, and it's 15 millimeters thick, radial with a square or rectangular output blower, squirrel cage fan. They're great fans. I mean, they're great for 3D printing. Great for layer coolers because radial fans in general put out airflow with a higher static pressure rating, more oomph behind it than an axial fan does of the same CFM. So given us an axial fan and a radial fan, so like a squirrel cage fan of the same size and the same power and the same noise level rating, the axial fan might put out a little more air if it's unloaded, either it's not in a funnel or anything. But as soon as you constrict the flows and you try and force them through like a nozzle, the radial fan almost always wins because just the nature of the way, it's almost like a pump, you know. Just the physics of it tends to generate a higher static pressure rating. So the people who designed the Fang had the right idea. You know, you put one of those 5015 fans on top of there, you know, get it up out of the way, and yeah, it'll pump a lot of air. So they got that going for them. It definitely outperforms the stock cooler in that regard. You're just moving a lot more air, and it's got more pressure behind it, which is good. The problem is that it is the airflow is fighting itself. You're jetting one from here, and you're jetting one from here, and they meet in the middle, and they just kind of crash. And, you know, a lot of the airflow ends up getting turned away before it even really wicks heat away from the plastic. So in an ideal situation, what you would have is airflow that just comes in cleanly from one side, swoops very laminarly, is that a word? Linearly, over the freshly printed part, and then just continues on out throughout the other side into free space, just whoosh, carries the heat away from it, offers no obstruction, and then more air comes in and just whoosh, keeps carrying the heat away. That would be the most efficient. Now, the problem with that is even though it's efficient, it's not even. you notice this. Like if you have really steep overhangs on one side, it might do a better job cooling from one direction than if the overhang is on the other way. And you do run that risk with something that cools from only one direction. So a Fang is designed to do two things. One, it delivers air in a pretty nice pointed way without constricting it too much, and it offers the air lots of space to go. And two, it's relatively even. It's kind of a compromise. Think of it as a compromise between a single-sided cooler and something like a circular ring shroud, like DIII, that completely surrounds the nozzle. The problem with those is they really don't allow the air anywhere to go. They don't give it places for the heat to escape. So a Fang is a pretty good compromise because it gives you plenty of space for the air to go, but it also does kind of cover some of your bases. It covers the left side and the right side. So it can be a pretty good compromise as long as it's pointed in exactly the right spot. I don't know. I do want to get more into fan shroud design.
Yeah, because I was thinking to myself, well, I'm going to be upgrading the CR10. I got all the parts now. I was at Earth. I picked up I finally picked up my Capricorn, so I'm happy to pick up that stuff because the Cult's been screaming, Grumpy and the rest of them all screaming at me to go Capricorn.
Go Capricorn.
Go Capricorn. Don't use other stuff. Just go Capricorn. It's like, fine, I'll go Capricorn, blah, blah. And then Barrett, and as you know, they sold Barrett on after giving him a little bit, and he's like, oh, yeah, Capricorn all the way now. It's like,
it's good.
Fine, I'll go
slippery.
Capricorn.
It's nice, flexible. It's tight tolerance. It's a good structured internal diameter. It hugs nice and tightly. It's good stuff, Yeah. It's good.
Plus, I got myself this kit right here. This is my V6 for the CR10. I got my filament for the CR10. This is a filament sensor for it. And then I bought this little bag. This is the sensor for a CR10 to do auto bed leveling. So
is that the H3D Studios?
That's correct. This is from Timothy Hoagland. I paid full price for this guy, so before you guys go, oh, he's getting you this stuff for free. No, this was all paid. This all came out of my own pocket. Thank you very much. But I wanted to use a genuine versus a clone because I've heard some stories about some of the clones not being the greatest. But also, it's finding a good clone is the trick also. Because I know a lot of there's like so many clones out there for the 10, and they're junk. They're pure garbage. That's the one thing that everybody should understand is that even though, it's better to buy an original than buying a clone, sometimes the clones work better than the originals in a lot of ways too.
Yeah. In some situations, I mean, okay, let's see what we're looking at here. We're looking at an inductive probe. That's a pretty standard piece of equipment, in industry. A couple of resistors, a couple of capacitors, whatever. Electronic components can vary in price and vary in spec. You've got some connectors, you've got some wires, you've got some circuitry that acts as a gate. So you just get the inductive sensor acting as either binary on or off. So it acts as an end-stop switch. Not a whole lot to go wrong in there, not a whole lot of components, but sometimes you can get them spec'd pretty cheaply and pretty wildly, and sometimes, depending on how things go together, even in a part like that, if you go too cheap, you can get something that will malfunction. That said, a lot of clones for that sort of thing are getting pretty good nowadays. A lot of inductive sensors, even the clone ones, are pretty good. I mean, their trigger distance might not be exactly what it's supposed to be, but it'll be fine for a 3D printer as long as it's consistent. Stuff like that. What you really run into issues are still in cloning is machining quality, service quality, and typically heat breaks is where you see that being the issue. In a lot of other areas like cloned hot ends, other areas like cloned boards, jury's still out, depends. Some are good, some are not, just depends. But on things where the machining quality is critical, like the inside surface of a heat break, I would say, go genuine with that. Just my 2 cents.
Yeah, so far I'm reading some of the comments here, and it's been kind of interesting what everybody's been saying. So basically, they're saying they got to keep you in the loop to watch what you come up with. I mean, Daniel's
Oh, thanks, guys.
it says here he goes. This Daniel guy is someone we need to keep in the loop, according to Apocalypse Survivor. And then
All right.
Chris Riley agrees with him, definitely. So you're loved now.
Anybody who follows me in this time period, I'll follow you right back on Twitter.
You hear that, guys?
That way I can stay with you. Yep. Anybody who
And-
follows me, I'll follow you back.
We need to get, and since we do need to get you a YouTube channel, since everybody's asking you to have a YouTube channel, we'll
All right.
we
all right,
will
all right.
work on it, guys. I can't
We'll
promise
work on it.
anything, but I mean, even
Yep.
even the phone does a good job of doing videos, so I wouldn't worry too much. All you need to do is get one of those cheap lavalier mics that have the 3-prong at the end, so you can just
Yeah.
clip it on and just
Plug that in.
tape it. Yeah, so you get like half decent audio. We are getting a little bit of
Yeah.
room noise, but you can't help that.
Yeah.
It is what it is
Yeah,
right
with
now.
better mic, that'll be fixed.
Yeah.
Yeah. Yeah, Ron here. Yeah, he knows the broadcasting stuff. I don't. Completely new to this. Did my first stream like a month ago, and it was terrible. We had all sorts of issues.
Yeah,
So
but
he'll
dealing with
teach me his ways.
we were dealing with that YouTube that hotel Wi-Fi that just went to heck on us.
Oh yeah, that was funny too. Yeah. Oh, we had some issues with that, didn't we?
Oh yeah.
Oh well.
Let's see. Interesting video
Yeah.
demonstrating on some airflow collisions, and one guy's equipment to virtualize it was going on vaping related. That's not a bad idea. Yeah, because the vape
That's what?
could show you the
It's
travel
a
of the
great
smoke.
way to visualize that sort of thing.
Yeah.
I wonder what you could do if you had like different colored, if you really dyed or tinted the airflows, if you could show, where they collide and mix and where the mixing is and where the dead zones are. My greatest fear with something like a Fang nozzle is that it'll be too good. It'll be too precise. If both of them pointed like right below the nozzle, and the two airflows will be very laminar and everything will just collide, and then it'll create just a high pressure zone where no airflow really happens right around the nozzle, and very little cooling happens right there. But on the flip side, maybe it's a little off center, or maybe one's a little stronger than the other. That would create a net flow around that area, which is probably more realistic. Let's be real.
Yeah. I mean, you can't have two fans to have the exact matching.
Yeah, that just never happens.
It'll never happen, exactly. Because the voltage can offset each other, and, both drawing from the same channel can actually cause, what is it, less pull I want to use?
Well, even if they're in parallel, and two fans aren't going to be binned exactly the same.
True.
One's going to have a little more resistance in the windings than the other, and yeah,
The
and
bearings,
the
everything.
two fangs are not going to have exactly the same. The bearings, oh yeah, and the level of lubrication. I mean, gosh, everything plays into it.
Yeah, exactly.
So-
So I'm not too worried about that. It's just like, the one thing I find interesting is the idea of airflow that we need for that to move around, because I know that the ring doesn't really do that, because the ring can trap in the heat, and that's not what you want to do. You want to
Unfortunately,
push
yeah.
out the heat.
Yep, you want to sweep it through. You just get that heat displaced, right?
Yeah.
You're trying to keep it out of the area.
Yeah. Now the thing I'm
So-
looking at is a fang that comes like straight down, but it seems like the two air ducts point on an angle inward, so they point like that.
Now you got it.
So it's like
You got it. That's actually exactly what we're doing on our big printer. Instead of two fangs that directly oppose each other, they meet, yes, but they're angled.
Yeah.
So there is a net flow from the back to the front, but at the same time, it's still hitting you from multiple angles.
exactly.
Working on it, but I think that will be more effective.
Yeah, and actually I found it on Thingiverse. Someone has it already posted, so maybe
Yep.
a good
Is
way
it
for
for
you
the
guys to
CR10?
grab it. It's for the
Do some
CR10.
experiments
Yeah.
with that. Yeah, I want to get like a little, I don't know what could do it, like an incense sticker. I need something more scientific, something that can produce a very steady, very constant amount of vapor. just pen handled size. I don't know. I don't vape or anything, but maybe there are some solutions like that. If I could just put like fog machine oil or whatever in one of those and just use that to test airflow. I don't know. I haven't really looked into it.
I think you might be able to modify a vape that it would put out the same amount of smoke.
More smoke, the better, as long as it's just steady. You know, I'm just looking for something with 100% cycle, just steady output, very fine opening, just so I can pinpoint, put smoke in different places and see where it ends up. If you guys have any suggestions for that, put those in the comments or, tweet that at me.
Yeah, unfortunately, we don't have a country that we could mail it out to him, Country being one of the guys who vapes. He loves to vape online, so he could probably give you a
He probably know a lot about that.
Yeah. Here we go. Incandescence works very, very simple. Vapes are more for shot bursts.
Okay, so that's not really what we're looking for here.
Yeah.
So.
One thing I thought I was going to talk to you about was the Gavelite idea for the other thing that we're working on.
Yes.
This might be, yeah.
We've been talking about that today and yesterday. Should we spill the beans? Should we keep it a secret?
Keep it a secret still.
Okay. I was talking with Jacob about that today too. We came up with some cool ideas.
Oh, okay, cool then. I was watching the channel, but I haven't seen anything coming up between. Yeah, I know you two have been working on it all day today.
No, yeah, it was just between two of us. I'll tell you what we figured out later.
Yeah, I'll see it in the chat anyways. But guys, if there's anything else that you guys have any questions about now that we've been talking a little bit more, I know we haven't even talked about building the Core XY yet.
Yeah, or the Z-Wobble. We didn't quite finish Z-Wobble.
Yeah. But like I said, if there's any questions right now, guys, you want to fire them off, or do we let Daniel go, or do we continue with Daniel for a little bit longer?
Yeah, I can stay for a while longer.
Yeah. You can join us in our search for YouTube greatness. So what's going on is I do this a little bit every so often. If someone needs a boost in their channel, someone I know, guys, if you guys remember, I don't know, Daniel, if you saw this kid. He built, he has a CR10, but he extended the Y-axis about 150 millimeters from... So let me grab a CR10. Grab it here.
Which model was CR10?
Not CR10.
The
sorry.
100 millimeter.
XY. No, Troxy XY.
Troxy. Okay.
This guy. So instead of the bed was extended. He basically put fiberglass all the way to here. To when I don't know if you can see the screen not well enough.
I can visualize.
Here we go. Okay, so he had it way off to one end. And they had the bed extended off to the other end. And all he was doing was putting down one layer. I wasn't sure why he was doing that, but didn't really explain the reasoning for it. But that's what he was doing at Earth. One, a roll of filament from filaments.ca. Great, nice white color. But, yeah.
Just one layer thick.
One layer thick. That was it. And I don't know why someone would want to do that, or if could you think of a purpose for it?
Must have had some kind of project. I don't know.
Yeah.
Maybe it was just testing it.
Maybe. Here we go.
You have a question?
We have something come up. Yeah. Apocalypse Survivor said, you were explaining software solutions to compensate for Z-Wobble, ?
Software solutions to compensate for Z-Wobble. Was I explaining that, or were we talking? Was that maybe when we were talking about the bed heating, like the Bang Bang versus PID loop?
I think so.
And there are two different firmware ways of dealing with heating. That's probably what he's talking about.
Probably.
Okay. Yeah. So that's not Z-Wobble proper, if you know what I mean. That's a Z-Wobble like thing. I would call it Z-banding, and it won't be exactly periodic. It'll just vary with whenever the bed is on and off, and that might not be exactly the same number of layers between issues. So that's pretty easy to recognize. Usually, if you hold it up against the lead screw, it won't match the threading. So
But yeah, that can be fixed a couple different ways. If it is due to the bed in bang bang mode drawing a lot of current alternately, one, you can switch that to PID. Two, and is maybe what you should do, is get a bigger power supply that can, smooth that out a little more, because you might be running it a little too close to its high end. You don't have quite enough headroom. I would prefer to run everything with a little more safety factor, right? It's not a good idea to run a power supply so hard that you're noticing some bad voltage drop and stuff. Or maybe it's just maybe it's the bed flexing, breathing. Like I said, single-sided PCB can tend to deform a little bit when you heat it up. If that's all it is, then, well, that's an easy fix too. You can just get a beefier piece of whatever you're mounting on top of it. So one thing people will say is, oh, I don't know, I stuck glass on top of my PCB. Why is it bending? And I say, well, everything bends, even glass. We think of glass as this ultimately stiff thing. No, glass is flexible. Everything has a flexibility to it. Even a sheet of glass, especially if it's something thin like 3/32 or inch. I mean, what is that, like 3 millimeters ish in Canada? Is that a typical glass size? I don't know. That's not that much stiffer than a PCB, really. I mean, like, yeah, it's stiffer, but it's not like a million times stiffer. It's maybe like 10 or 20 times stiffer. So the PCB will be able to flex that just a little bit, and you might see your print kind of flexing up and down. Now, as that happens, your layers will alternately get squished a bit more or squished a little less. And as they're squished a little more or less, the filament will press out the sides different amounts, which will make different patterns that are periodically visible as you go up in Z, which is why it kind of looks like Z-wobble. But it's not really Z-wobble. It's a totally different phenomenon altogether.
Yeah, sorry, I'm just pulling up this. Okay, so guys, well, I'll pull up something here. I'm going to disappear, but Daniel's going to stay on screen, so just stand by, everybody. I'm going to put in another display capture window here. Let's see if I can do this on a video capture device. We're going to be looking at someone else's page that I would like to get. I don't have that set up. Okay, I need to add another capture. Game capture. Yeah, add source. Okay, done. Capture Pacific window. We're gonna. Why won't you let me capture the other one? Okay, it's being buggy. Capture any full screen application? No. Cancel. I hate things with these screen captures. But what it is, I want to show you guys. Display capture, add source, add new source. Yeah, display 0. Okay, done. So as you guys can see, you guys are seeing the multiple 1,000 window type display. Let me move this up to here. Or maybe I need to make them above that. Okay. Well, we can't see Daniel, unfortunately, so I do apologize for this, guys. But what I wanted to do is bring up Making with Luke. Guys, he was only at 19 subscribers. Do you think you guys want to check him out? This is the guy that built the printer that I was talking about, the line printer that goes back and forth. We have a video of him going to...
Hey guys, welcome to the first video of Making with Luke. Here we are on our way to the Midwest Rep Rap Festival.
I'll check that out
a bit. Here that I'm
you want to drop that link in the messenger chat for me?
We'll do.
On. If not, it's whatever. But
cool.
Yeah, so I'll send you that link to his channel. But guys, let's see if we can raise this channel up a little bit. If you guys want to check out his videos, please subscribe and let him know that I sent you. Maybe that will hold some water. I don't know, but you know. The kid's smart. I mean, he's trying to do something that's kind of interesting and different. So, you guys want to show him a little bit of love? That'd be great. And I know,
how old is he?
I think he was in high school still. He's like, I think he's going to college soon. So, Yeah, he built a. He's already built a simple wood projector stand. This is his latest video that he started producing. So he's getting back into producing. He wants to produce more. He is young.
Cool.
I understand that, but I was just like giving him a few tips. Hey, you can pick up this and this. You know, it'll help your audio quality by tenfolds. You know.
Mm-hmm.
But yeah, here you go. Sent it off to you.
Be interesting to see if he gets to those. Oh yeah, hey, got the link. Thanks.
Yeah. So if you guys are able to, he's only 15. That's it. He's only 15. No, he has to be older than 15. He was driving a van.
I got started with printing at 15. Maybe that's a little out of date.
Maybe.
Might be 16 or something.
Yeah, it might be 16. But
I didn't get started until I was like 18, 19, maybe 19. I don't think I got started until I was 19.
Yeah, I didn't get started until
really
the last couple of years. So, like, I've always had an interest in the printing of sticks. I didn't understand what we were using the print at the time when I first heard about 3D printing. And then I found out, it was Weed Whacker line. I was like, Weed Whacker line, really?
Right, it's nylon.
Yeah, and then it went from Weed Whacker line to ABS to PLA to PETG to
Now we've got all sorts of stuff. You got ASA, we got fiber filaments, composites, carbon fiber, and all sorts of high-tech stuff.
What is the most strongest plastic that doesn't have any flex to it?
Good question. Is this a question from the chat, or is this?
Oh, it's just something came to my head because I was thinking of if I build a 3D printer and I go say if I take the X1 here and
this is a great question. I'm so glad you asked this. This is awesome. Also right up my alley. I love
instead of using like the metal, like instead of using like say a like an i3 a Prusa would use, if we would use something like this instead, what type of options would we have as plastic to print this out?
Sure. So, okay, there are a couple different mechanical properties that colloquially, just in the vernacular, we might sloppily refer to as strength of a plastic. If a part is, whacked with a baseball bat, we'd say, oh man, that took quite an impact and it didn't shatter. A glass might shatter if you hit it with that, and maybe a plastic part didn't. You say, oh, that's pretty strong. In reality, glass has a pretty decent tensile strength, and it might be stronger than the plastic. And by strong, I mean the proper sense. Like by the definition of strong, I mean like just tensile strength. You take one end and you yank it apart until it breaks slowly, and then at whatever point it yields, that's what you call its ultimate tensile strength, or yield strength. Sorry. There are whole courses on this. I had one of these in college, material science, and there are a whole bunch of different properties. You've got yield strength, you've got ultimate tensile strength, and they're a little different. You've got stiffness or Young's modulus, and that refers to basically, intuitively, how much force it takes to bend it a certain amount. It's a relationship that's linear up to a certain point in most materials, and you can quantify that, that slope, stress over strain and such as stiffness, and you can actually stick a number on it. And other stuff is a bit harder to quantify. For example, impact strength. There are so many factors that go into that. Oh boy, that the only way to do that is really with like making a standardized test. For example, they take these things and they put a little notch in it, and then they hit it with a thing, and then they see how much energy it absorbed to break the sample. And by putting stress concentrators in it, you can, if the sample is standardized, get a pretty good idea for how different materials compare in impact resistance. So anyway, let's recap. We've got stiffness, which a lot of people think of as strength, but that's not exactly strength, but it's related. You've got like impact resistance, related to strength, but not exactly strength. You've got maybe strength under heat, which is valuable in a printer, but not really what we're looking for. And then there's just like raw tensile strength. Now, out of a lot of the plastics we use, honestly, nylon is pretty good. And nylons vary in composition a ton. I mean, there isn't one type of nylon. There are a lot of different nylons. But nylon also tends to be pretty flexible, and the more moisture it absorbs, even after being printed, the more impact resistant it gets, which is interesting, but also the more flexible it gets. Now think about it. Do you want a printer with printed parts that are made out of rubber? Or would you want them that are made out of, like, stone? I would want them made out of stone. You don't want them stiff, right?
Yeah, well, I'd rather go stone rather than go rubber, but yeah.
Yeah. So, same thing. Even though some filaments are stronger than others in the sense, really what we're looking for is stiffness. Now, the funny thing about PLA, everybody disses it as not being very strong. What they really mean is not very durable. Durability is a soft term. It can mean, like, performance under heat or abrasion resistance or impact resistance. PLA is not very great at all those. If by strong you mean stiff or you mean actual, like, tensile strength, PLA is actually awesome, both of those. PLA is very, very stiff, especially when cool at room temperature, and PLA is very, very strong in tensile strength. So actually, PLA is great for printer parts. If it's not in an enclosure and it's not near something hot, PLA is awesome. It's easy to print. You can do a lot of tries because it's cheap, comes in a bunch of colors, whatever. And you can get nice, crisp edges. You can get, good layer cooling on it, yada, yada, yada. And you can get nice, hard, strong, stiff parts. It's great for brackets and things. Now, the exception to that would be if you're, like, carting a printer around and you're, like, dropping it on the floor or whatever, okay, then maybe a PLA bracket wouldn't be the best idea because it might break. Or if you're carting around and you stick it in your car and you tend to leave it on a hot day, ordinary PLA might not be the best idea there because it'll get soft and your printer might shift a bit. Okay, but other than those scenarios, PLA is great for, like, gusset plates and things.
So PLA would be probably my best bet then to go with.
Honestly, yeah. Now, next up after PLA is PETG. Now, PET polymers are kind of like a middle ground between PLA and ABS, right? People say, oh, they print like PLA kind of, but they're impact resistant like ABS. And yeah, that's true. They have about the same tensile strength as PLA in a lot of cases. The problem is that they're more flexible. But the trade-off is that they're much more impact resistant, and they have great layer bonding. They tend to have very high interdigitation of the polymer chains. So when they bond to each other, they tend to bond very, very well. And you'll notice if you hit them and you break them, when they shatter, they often tend to shatter across layer lines. They don't just shear off between layers like ABS and PLA often do. They tend to crack, like, diagonally across layer lines. That's actually a pretty good thing. That's pretty cool. That means your layer bonding is good, which we like that. We want our forces to be efficiently and effectively transmitted through parts between layers without having a weak point, a bottleneck in the strength, right? So PETG is pretty good, and it's a little more flexible than PLA, so maybe it's not great for, like, most brackets, but any brackets that are near heat or any brackets that are, like, maybe on a travel printer, it might be a good fit for those. Any brackets that would have impact, but I can't really think of any impact on a printer. It's a low impact situation.
No,
usually.
I can't. Unless you're going to hit with a Mack truck, then nothing's going to survive that.
Yeah.
But that's besides the point.
That's silly. Yeah. And then ABS, of course, is the other fan favorite. Then there are people who swear by ABS. Okay, I get it. You can have with it. It looks awesome. And they say, oh, it's so strong. Actually, it's not really that strong.
No, it's not.
No. But it is very durable. It's really durable. I mean, you can hit that thing with a hammer and it'll be just fine. Yeah, ABS is great for that. Unfortunately, printers don't usually see a lot of getting hit by hammers.
No.
Hopefully not, anyway. So the only property of ABS that you would really want to exploit in a 3D printer is heat resistance. It'll tend to keep its strength up to a pretty high temperature. Surface temperature, operating temperature is pretty high. So if you're running an enclosure, ABS might be a good choice. Something you should really be looking at is ABS, especially by hot end stuff. Well, now, if you do your airflow carefully, and you do your thermal management really carefully, you can use PLA, part coolers and things. just be careful. You know, I have a part cooling fan that's been running about 2 years now in PLA, and it's still working great, but it's not an enclosure.
Well, let me ask you this then.
Sure.
What do you prefer out of these two? Now we have ABS, which I know requires a lot of heat and requires you to heat up your whole chamber and everything else. So here's a roll of ABS I got from IC3D, which was really nice of them just to hand it out to me. This is supposedly their yellow filament. I think this is their same yellow that Fun King loves. So yeah, if Fun King sees this video, sorry Fun King, I have their yellow ABS. And then I got a roll of Atomics from their line. This is their PET G or PETG.
Yeah, I usually say PETG.
Yeah,
just because we spell everything else out, you know, we spell out ABS and PLA, and we spell out ASA and PET and PETT, so we might as well spell out PETG.
Yeah. PET. Well, it does not require a heated bed. It requires the heated bed, but it doesn't require a heated enclosure.
Sure.
And everybody's saying, oh, this is going to be replacing ABS. What are your thoughts about that? Just out of curiosity. Do you think it's going to replace ABS, or do you think we still should be printing in ABS because there are advantages in ABS versus the PETG stuff?
I like to say a tool for every job. You know, ABS has some properties that PETG doesn't quite have, and PETG has some properties that ABS doesn't have. For example, one of the strengths of ABS, or weaknesses, depending how you look at it, is the opposite of PETG. PET is pretty solvent resistant to a lot of common things. It'll repel acetone, no problem. It can be very watertight. It's got a lot of great layer bonding. You can print like liquid carrying stuff out of it. Pretty chemical resistant. ABS, on the other hand, you know, you can acetone smooth, but yeah, it's not as solvent resistant because the styrene component in it is pretty susceptible to a lot of common solvents. Now, that's right. The very property that makes ABS nice to work with, if you're a person who likes to acetone smooth things, means that it's not as great in some situations where you actually want solvent resistance. So, you know, maybe you need some of both on hand, because sometimes you want to acetone smooth something, and sometimes you want something that can't be smooth, you know, can't be dissolved in common solvents. So, you know, that right away there tells me that there are two situations where, you know, both will probably have a place.
Yeah, because I'm just thinking now that we have that 3D Gloop, which you were pretty impressed with. And I must admit, I've been impressed with that. That
was cool stuff.
Yeah, like, I mean, and they got beat off, this one guy, because this one guy twisted them apart and broke one piece. But you could see that where it was glued together, it was still stuck together.
Did it break in the print?
No, he broke an area that wasn't painted over with the glue, because the guy took the two handles and went like this, and snapped one of them off of one end. But where they were put together was still glued together.
That's cool.
I'm just like going, guys, you right there proves your gloop does what it needs to do. But now Apocalypse Survivor said something kind of interesting. He says, how does ULTEM or PI strength properties compare to PETG? I know that was going to be. I know that stuff is up your alley too. So.
Oh, it is absolutely up my alley. I love talking about this stuff. Now, this is like comparing a Lamborghini and like a Toyota. Okay, Ultim, PEI, PEK, that sort of thing. That's out of this ballpark. Okay, we're dealing with materials that have tensile strengths up to here, and you know we're dealing odds and ends, and they've got stiffness up to here and solvent resistance up to here. PEI, PEK, that stuff is like, wow. Okay, I mean sometimes it's used as an aluminum replacement. You know, in some aircraft stuff. I mean, that stuff is legit, but finicky to print with. That has its own set of problems. You need heated enclosures. You need to print that thing in a frickin' oven most of the time. So that's in a kind of another ballpark. But as far as strength goes, that's the way to go. I mean, those polyether ketones and polyether amides, that sort of stuff is really, really wicked strong. And depending on the blend you have, polysulfones are also very strong, and very, very solvent resistant. Those are all broadly referred to as like engineering polymers. If you guys ever want something interesting to look up, just Google polymer pyramid. The polymer pyramid is something people use to just kind of broadly classify polymers in a sort of a stack of, like, a hierarchy of usability, like melt processability and how cheap and easy they are to work with, versus how awesome they are for the really demanding applications, which also coincidentally means the harder they are to work with, because they have to be able to withstand more extreme conditions, right? Which means they're more extreme to mold and shape and whatever. So the polymer pyramid is kind of a way to classify these polymers into different levels of, like, categories. You've got your common stuff, and then you've got the weird funky stuff like Ultem.
Yeah, I just gotta go check something, but Apocalypse Survivor just chimed up. He says temperature and cost ... What else makes it hard to work with?
Temperature and cost. Oh boy. So yeah, cost, expensive. Think like the most expensive filament you've ever seen filled or whatever, and then like twice that, probably. This stuff is not cheap, not that easy to synthesize, and it's not easy to extrude. It's also very difficult to keep dry. It tends to absorb a lot of moisture, which means melt processing it is difficult because you got to dry it right before you print it. Even Stratasys in their Fortis printers, which are Ultem machines, most of the time, even they have issues with this material. It's tough stuff to print, and they will tell you, like, when you open a cartridge, you got to use it quick, because even though they're sealed with desiccant, the moisture gets in there, and that material will absorb it, and it will bubble, it will pop, it will lose layer adhesion, it will cause issues with clarity. Yeah, I mean the stuff has problems with moisture. So anyway, there are ways around that. Polymer scientists know, you just bake it at this temperature for this much time, and yada yada yada. Hot air dryers, it's a whole industry unto itself. Polymer drying is a big deal in the plastics engineering world. Injection molding facilities have polymer dryers running hot air or vacuums all the time. Making those plastic pellets as dry as possible is really important. And for engineering grade filaments, like polysulfones or Ultem and PEEK and stuff, where moisture absorption is pretty high, it's a big deal. You have to keep them very dry before you print. But the main issue facing them is shrinkage. If you think ABS is bad, polycarbonate is even worse. If you think polycarbonate is bad, that doesn't have nothing on these guys. I mean, Ultem has shrink rates far, far higher than even like polycarbonate does. It's a bear to print with. It's just hard, man. It's really hard to print with. You have to have a really hot enclosure that's really stable, and you have to keep its internal and external temperature really nice and constant, so that there isn't any shrinkage or warping forces going on, because this stuff is so tough, and if you get it printed right, its layer adhesion is so strong, it will warp off of anything you throw at it. I mean, it can generate a lot of warping forces. So it's tough to print with. You need a very hot enclosure, you need a very hot bed, you need very constant temperatures.
Well, let you know about something about PEI. My uncle used to work for, was bought out by Boeing. So they would do the wings for the Boeing planes and everything else. And I seen one of their ways that they produced some of the plastic that he needed for the wings, and it comes straight out of an oven. The thing is super long, and it just comes out smoothly, goes into a chamber for cooling time, and then after that cooling time is done, then they pull it off the chamber, then they reload like layers of plastic back and forth, the way it's spread out on these big roller sheets. And once that's done, then they put it back in the oven thing, and that thing sits for about good 3 or 4 hours as it melds itself around the metal frame, and then they pull it out again. And then they have to let it cool for 2 hours before they can even pull it out to put it onto the plane. Yeah. That is interesting when I was watching them do that. So that was probably PEI.
One interesting thing about that you just mentioned, it might be, it's one of the few plastics that's really commonly used in aerospace because it's self-extinguishing, it's very strong, it's impact resistant, it's resistant to chemicals, it won't like corrode over time, that sort of thing. It'll basically handle anything you throw at it, which is why it's one of the few plastics that's approved for a lot of like FAA use. But one thing you mentioned just there that was interesting that maybe some people don't know the significance of, but I like to highlight. You said like they let it cool for 2 hours before even pulling it out of the oven. Well, why do they do that? Well, there are some very good reasons. In polymers that shrink a lot as they cool, that shrinkage, especially if it's not uniform, will cause some very high internal stresses. You guys know Prince Rupert's drops? Like when you take some glass and you heat it up and then you drip it into water, and it's got this like a teardrop at the beginning and then it tapers off to this really skinny tail, a really fragile tail. You guys know those? Probably. There's a lot of cool science videos about those. So those, because of the way they cool, right? The outside cools first, and then it hardens, and then the inside cools, and then it shrinks, and it pulls the outside with a tremendous amount of force. There's a lot of tensile stress in there, and that makes them really strong. You can like smash them with a hammer. But with polymers, that can cause an issue. If you have tensile stresses like that within the part that are pent up like that, if a crack does happen somewhere, it all bets are off. Who knows what it's going to do? It can fail very nastily. So that's the main reason why when they're working with high shrinkage engineering polymers like that, they tend to take everything very slowly and very cautiously. They heat up slowly, they cool down slowly. So that way shrinkage happens all kind of uniformly, and that way internal stresses are lower. That way the part is A, less likely to fail because there's less force on it, and B, if it does fail, it'll fail a lot less violently because the internal stresses on it are low. It's not going to rip itself to pieces.
Yeah, and that makes sense. I mean, the way I was told is that it's extremely hot and they need it to cool down to room temperature before they can apply it to any type of to the metal extrusion that they want to apply it to. This is what I was told. That needs that cooling time to cool so they can actually apply it.
Yeah, and you might think, well, why don't they just like quench it with water? The faster they cool it, the more of them they could process, right? The more wings more money to make. No, you don't want to do that.
Yeah.
Gotta let it cool slowly. That'll be bad. Mm-hmm. That'll be really bad.
It can actually cause the plastics to explode, actually, I've been told. That because the molecules really are so bouncing around still inside of it. You're trying to cool down the molecule. The molecules will go. It's just the type of the way the molecules work with each other, and it becomes a violent explosion.
Internal stresses build up, it can just shatter. I've seen some steels do that, not firsthand, but in the videos, and I've read a lot of things. Somebody will say heat treat a knife. Another hobby of mine that I haven't been doing for a while. I should get back into that. And in the martensite form, where it's hardened and the internal stresses are high, they'll just leave it on their bench and then come back the next day and the thing cracked under its own stresses. Like it just shattered like glass and there's fragments of metal all over the place. Internal stresses are a big deal in industry, and dealing with those is a pretty important job. People run a lot of simulations, and with plastics especially, that's pretty important.
Yeah.
So that's one of the reasons why it's so hard to print with.
There's something you could do as a video idea and just show, like, hey, heat up a knife and just show them what it can do under, to explain the plastics and the heating. Might not be a bad idea if you're putting together a video. You can do that and watch. Why did this happen?
That'd be interesting.
Then
It'd
explain
be interesting to take a print, like heat up a solid piece of plastic and do something with high shrinkage, like a sample of Ultem, and then quench it. You see if we can get it to like explode under its own shrinkage. That'd be difficult to do, but I'll maybe crunch some numbers, see if we could do that as an illustration.
Yeah, well, it'll give people more of an idea. They can see it, why you wouldn't want to do it. But I want you to take the precautions so you don't injure yourself, okay?
Mm-hmm.
That is one of the rules here, guys. I don't want any of you injuring yourselves because then you can't watch my videos. You can't participate anymore. You might be dead.
Sure.
We don't want you dead. That's all I'm saying.
Trust us. We're trained professionals. Well, one of us is.
Okay, maybe you're a trained professional. I'm just a trained idiot, personally.
Okay. I don't know.
I used to
largely
take
self-driven.
like for me, when I was a kid, I used to take apart my parents' converters. Why? Because I wanted to know how they work. I want to know how does a button
Of course.
take that to
Yeah.
that. And it's more like my parents never pushed me to go into engineering. I think that was a bad mistake on my part. But if they pushed me that way, I might have actually became something more. Who knows? Just saying.
Who knows? Yeah, you probably would have been a good engineer.
Well, I have the
And
auto
question
engineering
from chat.
background, which is kind of funky. You know, I've gone to places where they're like, "Hey, you should be working for Toyota." I'm like going, "I can't stand working on cars anymore." The older cars, yes, 100%. Give me a nice Chevy 252 with with the power of the Hemi, you know, V6. I can get that baby purring in less than a day. You give me something like a new Ferrari, was it Ferrari H325 with horsepower of 755, controlled by 3 computers? Yeah,
I wouldn't even know where to start. You know, it's all computer. Oh,
It's all computer now. So you got to go through board A, board B, and board C and find out what they're reporting. Once you know what they are reporting, then you have to go into the code and adjust for it. Plus, also, you probably have to look at your timing belts, look if the timing belt it has the right strength, then what is causing this to fail, the fire punch, and it's like, yeah, I don't want to deal with that anymore. It's just gotten, when you add in computers to do what we've been doing for years with steam engines, I really then go, are we losing something with that? Or are we gaining something else with it? I don't know. You know, it makes it harder for mechanics to actually diagnose a problem. Just saying.
that's a lot harder.
Yeah.
I mean, reliability is up, but at what cost? You know, mechanics have a lot harder time dealing with these things.
Yeah, and they have to go back to school and learn all the electronics and the programming that's involved in
Yeah.
it. I mean, I've heard of
have to be a
Marlin.
coder to be a mechanic.
Yeah. You know, it's like, oh, why did you take computer programming? Because I'm a mechanic. That's why.
I want to work on cars. Cars use code? Oh, heck yeah, they use code. Oh, honey.
Yeah, like, I mean, I remember back in the GM days, just before GM, back in 2005, 2006, 2007, 2008, they were using computers back then. But theirs was really good because what you do is you take 2 wires, you plug it into the device, and it reads you out a bunch of code. And it gives you a bunch of flashes and tells you what the code is. Easy, simple, open your book. Okay, so it's saying there's an issue with the timing belt. Okay, pop the wire, go under there, you flash your timing light, read what the timing is, and go, okay, yeah, timing is off by 3. Readjust your timer, start it up, boom, everything's working great. You plug your ring back in, and you look at the code, and it starts reprocessing the code, and then it tells you if it's good or bad. Okay, bad again, pull it out.
Pretty
Good.
logical.
Boom,
Yeah.
done. You're simple.
It's so
Fixed.
straightforward. You just follow it through the steps. It just kind of guides you through the process. Wish 3D printers could do that.
Ah, yeah, that'd be nice.
Yeah. Yeah, instead, you know, you have to kind of piece together your own mental workflow, and it depends on what your machines are prone to. You know, some machines are prone to some things that others don't even, you know, have as an issue. Like, for example, this Tronx EX1, you know, heated bed means it's automatically immune to a host of problems that power supplies and, you know, heated beds can interact with and cause. So,
Yeah. Like, don't get me wrong, the printer print's
that's nice.
great.
You know, there are certain things you know you don't need to look for.
Yeah. Like, this printer print's great, don't get me wrong. But there are some days where it's just like, I would rather print with a heated bed, personally.
Yeah, I always recommend it. I mean, anything you can do to just reduce the amount of shrinkage you're dealing with, even if it's a low shrinkage material like PLA or sometimes some PETG blends, it never hurts. It just use a heated bed. It helps. It just always helps. And people might say, "Oh, I don't need a heated bed. I print with PLA all the time, and you know, I don't need it even on big parts." I say, "Okay, you know, maybe you're getting good results there." But where I draw the line is if they say, "Oh, nobody needs a heated bed on PLA," I say, Think, you know, we got some people printing with things that are, you know, a yard wide, and you mean to tell me the thermal gradient on that is fine to have PLA that's even, you know, a fraction of a percent of shrinkage? you don't think that's going to fold in on itself? I beg to differ. You know, heated beds are really necessary at some things, or even heated enclosures, which we'll be seeing more of in the next couple of years. But I can talk about that later.
Yeah.
Well, guys, heated beds help. They really do.
Yeah, hate to break up the conversation, but guys, we are running late. It is already 11:47, so as I know it, I am starting to feel the tiredness kicking in. So I was going to kill this anyways, but before I kill this, Daniel, how's your Twitter following just going right now?
I don't know. I'm seeing a couple notifications. Let's see what I got. 1, 2, 3, 4. I'm seeing 4 new follows. I think 3 or 4 new follows. That's cool.
Oh, someone just donated $10.
Follow you guys all back.
Yeah. Buckler Survivor, thank you so much, buddy, for donating that $10. That is really cool.
Wow.
Yep, that's why you heard that. I don't know if you heard it, but the cha-ching, 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 or you didn't hear that, Dan?
I didn't hear that.
Okay,
that doesn't come through. But
so yeah,
that's awesome.
Apocalypse Survivor, thank you so much. You know, this is why we do this. I want to be able to, buy more printers, technically, but I also want to be able to, bring value, and I guess I brought you value for donating that $10. I really do appreciate it. Yeah, everybody got to work in the morning, so we're going to cut this. I'm going to cut this now. Daniel, stay online because I just need to talk to you for a few seconds. Guys, look him up on Twitter. Remember, it's Fiddler. Techie Fiddler.
Yep, Techie Fiddler.
So, guys, go check him out, and thank you so much for watching, everyone. Everyone have a great night. Once again,
thanks for tuning in.
Yep. And we're going to make sure Daniel gets his own YouTube channel. Or
yes.
Or we'll do what we can do to put his videos on my channel, and then I'll just reap the rewards. No, I'm just kidding. I'll share it with you, man.
All right. Yeah, thanks for tuning in, everybody.
Yeah. Bye, everyone.